Oh, well, hello, Tube. Uh-oh. I don't have any of my Streamlabs stuff. Whoa. What's going on here? How do I get those back up now? Hold on. Cloud bot. Entertain and moderate your channel with a cloud. Well, hold on, don't look. Alright. I don't know why that hasn't been a thing. What is going on here? Please make sure this information is private. How do I? Oh. All right. Is it working? All right. Is it working? I think it's working now. I got my chat. I have audio. I have video. I'm not sure about OBS, to be honest. I might go to just to Streamlabs to see what it's like, because I mean, trying to get Streamlabs to do things with OBS, and OBS is kind of likes to crash on me. Why not just go to the source? So maybe I'll try Streamlabs next time to try to avoid crashing. Am I still live? That's so weird. Let me go back. Sorry I'm late. I say that a lot. So I got chat, I got that, and I got that. Come on, switch accounts. I was doing a Pomodoro live a little while ago, and decided to run and get a coffee. I was already bad today, so like I'm just going all out on the milk. I try try not to do milk and cheese and stuff, but I had pizza for lunch. I wanted a coffee monster that has milk in it, so then I'm like, you know what, I'll just go across the street to Arby's and get some poppers. I haven't had those forever. So I went there, and then they had the mac and cheese back again too. So I got the mac and cheese and I got the poppers. But I was sitting there for like 10 minutes because Arby's is the slowest thing on the face of the planet. I think the only thing Arby's might be faster than is Burger King, and that's not saying much because Burger King, you could be there for 15 minutes for. They make you wait for 15 minutes because they're making it fresh, and then it's ice cold when you get it. At least from my Burger King. I don't know, your Burger King might. So anyway, it was still good though. Like it kind of hit the spot. So yesterday I ended the stream early because I got hungry and it was starting to get late. And I'm like, well, I live in a small town, so it's like, 24 hours really isn't much of a thing here anymore. At least since the you know what. And I might be talking to the boy. I better make sure that I'm actually live still. But anyway, okay. Since the you know what. All right. Anyway, so there ain't no. We're starting late, but we're not ending it early because I ate. I got caffeine. I needed this. Like, I love Professor Messer, what he does for us students, giving us essentially what we need to know for these CompTIA courses or certifications for free. But man, he can put me in a narcoleptic sleep. So, yeah. I still haven't greased the chair. So here's the plan. This week I have the kids Wednesday through Monday, and I'm not sure. I'm unless I stream early, which is a possibility. Excuse me. Wednesday and Thursday, I won't be streaming. Friday, Saturday, Sunday, Monday, I could probably get away with it. If I bribe the kids and we stream some Phasmophobia for a little while, so then they'll leave me alone to do some work, to do some studying. It sounds terrible, but so the goal for tonight and tomorrow is bang out as much of the video for these Python classes as possible, and then I don't know how long, how the length of the videos we have left. We might be able to look it up here. Here's my Pomodoro timer from earlier. In a perfect world, we'll be able to just finish up the videos tonight and tomorrow night. I'm on vacation this week. I don't have school this week, so I really want to get this done this week. I don't want this dragging on until when school starts. Let's see here. So we are halfway through. It's going. Oh! I thought we were halfway through that. I clicked on the wrong one. So I should have just wrote that down while I was at it. Okay, so let's get a Word document here. And we will where am I? Course. I don't like how these are laid out at all. Problem set 3. So I'm in the wrong problem set here. And I'm in the wrong... Who are you? Oh, I see what I'm doing. Okay. So we're in here. Right? What is going on? It didn't save my progress in the video. Problem set. Because I'm also not on the. I'll show you what I'm looking at here. So this is what I'm looking at. And you know, how am I supposed to know which problem set it is? And if I hit play, quit doing that to me. So that's introduction. This would be, that also says introduction. It's only 4 minutes. What is going on here? Courses. Resume course. Get out of there. Lecture. We were on this video. Or were we else? Name error. Try accept. No, we didn't. Snacks. What is this? That's not where we were. I am so confused. Who's this guy? Okay, this is the... What did I click on, by the way? Alright, so we were in loops. Where'd you go? What am I missing? What is going on? Is it going on to this screen somehow? No. Okay. So it's just like this is bro. Oh. Well, that's unfortunate. We'll have to figure out where I was. And it just disappears again. You're having problems. Let's see here. So we were halfway done with that, roughly. Gotta do exceptions. This one's 45. So we'll say... oh my lord. Stop. So 120 minutes is 80. So we have 40, 45. By the time I figure this out, the whole night's going to be gone. Do I have some sort of a pop-up blocker going on? Hour and 17 would be 60, 77. 77. Oh, there goes OBS now. Okay. 77. Oh, shoot. Which one was that? Was that libraries? I wasn't paying. Okay. Units test. That is really annoying. So 51. 51 for unit test. That's annoying. An hour and a half? Oh, man. Well, that's going to keep playing. Oh, it's not. Okay, so 90. 90. Was that file? That was file O, right? Okay, file O. Well, that was 92, so we'll add 2 minutes to the regular expressions. Oh, whoa, 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 whoa. That's 120, we'll say 127 then. I don't know if we're going to get it done this week. Not unless I do some extra streaming. Which, I mean, I can probably figure out how to make it work. Object-oriented. Whoa! Whoa! 120, 167, 168. Man, they're gonna make us work. And etc. This one will be short, right? Or not? That would be 120 plus, we'll say 30, 150. Should have done this in Excel. That would have been a lot easier. Now I gotta calculate it. So we have, say, 40, 45, 77, 51, 90, 127, 168. I hit the wrong button. 168. 150. Whoa, 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 whoa. It's 150. 748 minutes divided by 60. That didn't work. Because I didn't. 748 divided by 60. So we got 12 and a half hours. I don't know if that's happening in 2 days, but I guess I better stop screwing around because, I'll be working along too, so that's gonna eat up some time. Alright, let's get to this. I should have started off with this, but anyway. So in the description below is a link to this class along with the license. Let me pull up the license real quick. So we can talk about that real fast. So the reason why I can stream this is because very generously they have it under this license, which allows me to copy and redistribute the material in any medium or format. So I can watch it while streaming and working along with it. And all of you are welcome to work along with me. That's the goal. I would like to motivate people to learn something, to learn some Python. Even if you're not into programming and stuff. I'm not really into programming. I just think it's a useful skill to have. And, if you know how to program, you can always adapt things to your own life. So, can remix, transform, and build upon the material. I mean, I don't know how much of that I'm actually doing in this. but you can see all what I'm doing. So take that for what it is. Credit, like I said, there's a link to the class down below, completely free. You get a little certificate at the end. You can spend some money, a couple $100, get a verified certificate. And they're not affiliated with me in any way. They didn't tell me to do this. I'm doing this on my own accord. I non-commercial. My channel is not monetized. I'm not making any money off this. I have no access to tip. I don't have a link or anything to any tip jars or anything. I'm not making any money off this. If for some reason someday my channel does become monetized, I'll go back and unmonetize these videos. If you do see an ad on these videos, it's YouTube. It is not me. And now YouTube applies a license or a license to anything you upload. However, if you use my material, if you use this, I'm not going to copyright strike you. I can't copyright strike you. Just pretend like I'm using the same exact license that CX50 is. You can use my videos for whatever you want. I don't really care. So, there. I think that's it. That's pretty much it. So, I'm going to try to get to kind of where we were at yesterday. I think I might have been ending it on a formal protest. I forget if he was doing... oops, wrong one. I forget if he was doing more Harry Potter stuff. I formally protest to the Harry Potter stuff. Also, if you're part of the, if you're watching it live or part of the rewatch crew, I'm trying to come up with a name for the audience of this channel. I have a little poll out. My personal favorite is Glitch Gang. I think that's kind of funny. But I have a poll out with some options. Go vote on what the audience should. Because I like when channels have like nicknames for their their community. So there's like the 404s. There's the Glitch Gang. There's I don't know. There's a few of them to choose from. Go choose the one you like. And if it's Glitch Gang, even better, because I may end up overriding with the poll anyway and going with Glitch Gang just because I really like that. But if you would like to become a member of the Glitch Gang, hit that subscribe button. That helps out the channel a lot. I've been hemorrhaging subscribers because this is a drastic difference of what this channel used to be. So as people are seeing it, they're leaving in droves. Is that the word I want? They're leaving in mass. So I need to get the people in here that enjoy this sort of content. Like, subscribe, share, all that noise. So let's see if I can figure out where I left off. I think it was... We'll start here. I think it was a little farther along.
Look more closely at these lists. It turns out that in Python and really in programs in general, it's useful to have a list of values.
Yeah, we did lists.
Work with more. So in very appropriate
Let me
names,
double check the volume here, make sure it's loud enough.
You could say you would stay student.
Make sure you can hear me, hear the video.
It's not unreasonable to do something succinct in a loop like this. For S in student, using maybe the same that the list itself begins with, but again, why bother? Repeatable if you have a list of students, iterate over them one student at a time. Let me pause here to see if there's now questions about lists, as I've now defined them, a list of strings in this case, or using a for loop now to iterate over and print each of those names.
Yeah, so is it not necessary to initiate student in this case, or we can just declare a variable in the loop?
Good question. You do not need to manually initialize it. Python takes care of initializing the student variable to Hermione first, then Harry second, then Ron third. Unlike other languages, you don't need to initialize it to something yourself. It just exists and it will work. Other questions on loops and lists in this way?
Since you described break, so is there any concept of continue so that we can skip a particular case in loops?
Yes, you can continue using another syntax as well. We haven't shown that. For now, we focused only on break.
Okay, sure. Can this for loop work with either hash tables or different kind of type tables or arrays?
Indeed. So we're getting ahead of ourselves there, but there are yet other types of data in Python, and indeed, you can use a for loop to iterate over those as well. Anything that is iterable, so to speak, is a piece of data that can be used with a loop like this. But more on those soon. In fact, let me transition here to show just another way of solving this same problem, because up until now when we've used loops, we really have relied on numbers, and that's fine if you prefer to sort of stay in that space. Suppose I did want to iterate using numbers like I and 0, 1, 2, and so forth. Let me propose that we could change this code as follows. If you would prefer to think about, or if the program you're trying to implement requires that you use numbers like this, you might do this. For I...
By the way, I was formally protesting this section. Let's go ahead and... No, okay, so this is where we should be. What is going on here? There we go. Alright. What is... That is... I am a mess today. Okay, here we go.
Well, I don't want to just say students, because then I is not going to be a number. I is going to be literally Hermione, then Harry, then Rob. I need to iterate from 0 to 1 to 2, right? If I know a list with 3 elements, has these locations, 0, 1, 2, I need to create a loop somehow that starts at 0 and ends at 2. Previously, when I wanted to do that, I needed range, but this 2 is not going to work. I can't just say in the range of students, because students is not a number. It's not an integer, so you can't pass it to range. Range expects an integer. But there is a solution here. It turns out that there is a function in Python called length, or len, L-E-N, that will tell you the length of a list, and other things down the line too. And now I think I can assemble these building blocks in a way that can allow me to use numbers in this way. So range doesn't take a list of strings, it takes a number. And ideally that number is going to be 3. So
okay, for some reason when I hit...
Get a range.
Okay. I don't remember length from my class. I don't remember that being a thing that we discussed.
Range of values, 0, 1, and 2. So I think I can nest my functions like this. If I first get the length of the student's list, that's going to be 3. Then I pass that return value as the argument to range. That's going to give me back a range of values, 0, then 1, then 2. And what that's going to allow me to do then in code if I want is not just this. I could do print now students bracket I. And this is now where the syntax we're seeing is getting very expressive, new, and perhaps unfamiliar. But if I can do open bracket 0, close bracket, or open bracket 1, close bracket, or open bracket 2, close bracket, turns out I can actually put a variable in there, and I can express any number inside of those brackets so as to print these all out dynamically in a loop. Let me do this. Python of Hogwarts.py, enter, there's Hermione, Harry, and Ron. And now if I'm just curious, if I just want to poke around, or maybe I want to do a ranking, like who are the top 3 students in the school or in Gryffindor, well, I can print multiple things at a time we've seen. Let me print out not just the students at location I, but rather let's print I first, and then the student at location I. So 2 things to print, and we know that print can take 2 arguments. We've seen that before. They'll be separated by a space. Let me go ahead and rerun this. Now I see that, okay, Hermione is the top student, but she's in 0th place. That's a little weird. Like, we don't need to show the human using my program that we started counting at 0. I can clean this up. I can just add 1 to the I up here, and now we see sort of a top 3 list of students. Hermione's number 1, Harry's number 2, and of course Ron is number 3. So we can get access to all of those same values as well. All right, any questions now on these lists? Questions now on these lists? this length, these ranges, or otherwise.
My question is for I in range. Can you explain this once more?
Sure.
Still looks cryptic.
So let me rewind in time. We started off doing this for I in 0, 1, 2, and then we printed out meow 3 times in that way. The way that the for loop works is that it creates for you a variable that I've called I, but I could call it anything I want. It then assigns I initially to the first thing in the list. It then automatically assigns I to the next thing in the list. And then it assigns I to the third thing in the list. And each time, it does all of the indented code underneath. We realize, though, that this is not going to scale well if I want to do something like 1,000,000 times. So we introduce range instead. That has the effect of doing the same thing. It returns to me a range of values, a list of 3 things, really, so the behavior is exactly the same. If we now fast forward to this Hogwarts example now, though, what I'm doing is just combining these smaller ideas. I'm still creating a for loop. I'm still creating a variable called I. I want to do it over a range of values, but how many values? Well, if I use the length function and pass to the length function the list of values, length's purpose in life is to tell me how long is this list, and it's 3. So that's almost as though before I had just done something like this, but I don't want to hard code 3. I want to dynamically figure out how many students are at Hogwarts. So I'm just composing, or nesting.
I think it makes sense. We'll find out when I do the problem set.
All right, if I may, let me transition now to in Hogwarts still to introduce one final type of data before we combine everything with a few final programs. It turns out in Python, there's not just strings, not just ints, not just floating point values, not just bools, not just lists. There are also what are called dictionaries, or dicts, which are a data structure that allows you to associate one value with another. Literally a dictionary, like in the human world, if you were to open a dictionary, be it in English or any other human language, what's inside of a dictionary? Well, it's a bunch of words and definitions. A computer scientist, though, and a programmer would describe those more generically as keys and values. Something associated with something else. That's all a dictionary is. It allows you to associate something with something else. And notice, this is already more powerful, more interesting than a list. A list is just a set of multiple values. But a dictionary is sort of two-dimensional, if you will, just like a human dictionary, a book. It associates something with something else, like words with their definitions. Now, what does this actually mean in practice? Well, suppose that we wanted to keep track of who is in what house at Hogwarts. Well,
I don't know why it keeps not letting me use my spacebar to stop it. Anyway, I do believe we use dictionaries in my class. So in my class, the final project was like a word-based game, and part of that you had to like go through a house and do certain things, and I believe that we use dictionaries. I should still have that somewhere saved. I should pull it up, and we should look at it.
Do it using lists alone. Let me go back to VS Code here, and let me just temporarily, but in a way that I'm not going to like ultimately, let me create another variable called houses, set it equal to Gryffindor, corresponding to Hermione's house, Gryffindor corresponding to Harry's house, and Gryffindor corresponding to Ron's house, and let's add Draco in there, so we now have 4 instead of 3 students, just so we have a little variety, and he was in Slytherin, so now we have 2 lists. And we could just agree amongst ourselves that whoever is first in the students variable lives in the first value in houses. Whoever is second in students lives in the second house. Who's ever third in students lives in the third house. We could do that. But honestly, that is going to break down quickly when we have a lot of students, when we have a lot of houses. And what if we want to keep track of more things than that? What if we want to keep track of every student's house and the Patronus?
Be so much easier to do this in SQL, I'm just saying.
This image that they conjure up magically, well then we need a third list. Like, this is just going to get messy quickly if we're just on the honor system using multiple lists where everything lines up logically. It doesn't end up well when your code gets more complicated. But I do want to implement this idea. I want to associate something with something. A student with a house, a student with a house, a student with a house, and so forth. So how can I go about doing this? Well, let me go back to my code here, And let me propose that we do this using a Python dictionary. And this is the last of the new syntax, really, that we'll see. Here's the new syntax. Instead of using square brackets, we're going to use curly braces for dictionaries as well. We've seen curly braces in the context of F strings, completely unrelated. Sometimes you run out of keys on the keyboard and the authors of a language need to start reusing symbols in different ways. That's what's about to happen. We're using curly braces in a different way now. So let me create a variable called students, and let me go ahead and set it equal to open curly brace and close curly brace. This is an empty dictionary at the moment. And here's how a dictionary works. It allows you to associate something with something else. And you do that like this. Hermione, quote unquote, colon, and then the value thereof. What do you want to associate with Hermione? Well, Gryffindor. What do I want to associate Harry with? Well, I want to associate him with Gryffindor. What do I want to associate Ron with? Well, I want to associate him with Gryffindor. Well, this is actually not going to, this is going to get very ugly quickly. Once we add in Draco and Slytherin, my code is going to get too long. It's going to start wrapping. So this is purely aesthetic. It is perfectly acceptable in Python and other languages to format your code a little more readily and just add new lines if it makes it more readable. And one way of doing this might be as follows. I still have my curly brace up here. I still have my curly brace down here, but notice it's a little more readable now in that I have my keys on the left, my somethings, and my values on the right, my other somethings. It's just a little easier to skim top to bottom. You could format it differently as well. But I'm going to go ahead and add in now Draco, who lives, of course, in Slytherin. So now I have each of these keys on the left and values on the right, which is really, again, just a code implementation of this idea. A little chart that you might write up with paper pencil when associating something with something else. So how do I now use this code in an interesting way? The syntax is almost the same. If I want to print out the very first student, Hermione's house, I could do this. Print out the name of the variable, but I need to go inside of the variable. I need to index into it. And what's neat about dictionaries is that whereas lists have locations that are numeric, 0, 1, 2, Hermione, Harry, Ron, respectively, dictionaries allow you to use actual words as your indices, so to speak, your indexes, to get inside of them. So if you want to print out Hermione's house, the key you care about is quote-unquote Hermione, and what this syntax here will do, notice it's not a number 0 or 1 or 2, it's literally Hermione's name. This is like going to the chart earlier and saying, all right, give me Hermione is my key, Gryffindor is the value. That's what we're doing here syntactically. We're looking up Hermione and getting the value thereof. So if I go back to my code, that should print out Gryffindor. And if I do this a few times, students bracket, quote unquote Harry, should give me Harry's house. Print students, open bracket Ron, that should give me Ron's house. And then lastly, if I do this with students bracket Draco, that should give me Draco's house. Now it's a little manual still. I bet we can improve this, but let me run Python on HarvardX and we should see Gryffindor, 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 Slytherin, which is exactly what we'd expect. Now all we've done again is we've just now moved from having just a simple list of names to, again, sort of 2 dimensions, associating, like we would on paper pencil, something with something else, keys with values respectively. Allow me, if you will, even though I realize this is getting a little fancy, allow me to escalate things slightly here and transition from looking at just, for instance, that pattern there, just hard coding those values there, to actually printing these out more dynamically. Let me go ahead and use our loop, and this question came up earlier as well. Let me go ahead and say for each student in students, go ahead and print out, for instance, the student's variable at, well, let's just say student first. Let's keep it simple. So this is not going to be that interesting yet, but when I run Python of HarvardX.py and hit enter, notice, what should I see? Let me take a question here to see, what am I going to see when I hit enter now? When I'm doing for student in students.
Yeah, I think we will only see keys.
Perfect. So good intuition. It could have gone both ways. Could have been values, the houses. But when you use a for loop in Python to iterate over a dictionary, by design, it iterates over all of the keys. So we should see, I think, Hermione, Harry, Ron, and Draco. Let me hit enter now. Enter. And indeed, you're exactly right. We see just the keys. But that's not really that useful if what I really care about is who lives where. can I print out both? Well, I think I can. Let me go ahead and do this. Let me print out not just the student's name, the key, but let me use the key, their name, to index into the dictionary. Right? If I know the word in the dictionary, let me look up its definition. If I know the student's name, let me look up their house. And the syntax for this, just like a list, is students, bracket, and just like in the past we used I, when I was a number, we can also, with a dictionary, use a string. So if the student's name is the key, then this syntax, students, open bracket, student, close bracket, will go to Hermione's location and get back her house. We'll go to Harry's location and get back his house, and so forth. So if I do Python of Hogwarts.py enter, now I see Hermione Gryffindor, Harry Gryffindor, Ron Gryffindor, Draco Slytherin. Now it looks like I've given them all new last names, but I can clean that up. This is just a print thing. Let's go ahead and change our separator from the default space to maybe a space, comma, and just using print features now, let me run the same program again, enter. Now I've just got some nice pretty commas in there to make clear that Hermione's last name is not in fact Gryffindor, but that's just a print detail. Any questions then on these dictionaries and what I've just done? Questions on these dictionaries and this looping over them here?
I just can't get my head around the for student in students. Does if I'm just correct me if I'm right. Does that mean it imports the list of students and uses the indexes, or in other words, Hermione, Harry, and Ron, as the indexes in the actual the list of students?
Correct. So this is just a feature of Python. When you use a for loop with a dictionary, what happens is this. If this is the dictionary here with the keys on top and the values on bottom, you get to choose what the variable's called. I called my variable student just because it makes sense, because I want one student at a time. And what the for loop does, just like it did with numbers before, the 0, the 1, and the 2,
so
it allows...
What I think he's saying is that when the way he wrote it, it automatically... Where's my pointer at? It automatically, just by saying for student, that for student tells Python that these are student, which are the keys. And we know it's the keys because it was what was before the houses, basically, or before the colon. I think that's what he's trying to say. That's how I'm understanding it. And that's how I understood it back in the day, because it doesn't make sense, because you're not, if you're looking at it from like in the eyes of a noob like me, we're not telling that Python that was students and then using a for students. It's just automatically doing it. It's almost like it's magic, like Harry Potter magic.
Allows me to, for instance, set student equal initially to Hermione's name, and then the next iteration of the loop, the next cycle, sets student equal to Harry's name, then Ron, then Draco. It just kind of happens automatically. Like, that is what the Python interpreter does for you when it sees a for loop like that. So it's very similar in spirit to iterating with a for loop over a list, but rather than iterate over the numeric location 0, 1, 2, it iterates over the bold-faced keys in this representation here graphically. And allow me to give us one other example on Hogwarts before we look at one other familiar domain. At the risk of things escalating
Still formally protesting Hogwarts
a little bit, let me propose that we continue the story with one final Hogwarts example like this. What if we have more information about each of our students? And this is kind of inevitable, right? If you're implementing a program that's a database with people or customers or employees or anything else, you can imagine having a lot of data about anything you're representing in your program here. For the sake of discussion, suppose that every student at Hogwarts, of course, has a name. They have already a house, but they also have a Patronus. For those unfamiliar, this is the animal or entity that comes out of the end of their wand when they make a certain magical spell. The point here being is that we want to associate not just one thing with the student, but multiple things as well. Their name, their house, and their Patronus in this case. Well, what might code like this look?
What the heck is a Patronus? Is that their spirit animal or something? Like, what are we doing here?
Like? Well, let me go back to Hogwarts.py and let me start fresh for just a moment, and let me propose that I enhance this with a bit more data. And this data is going to look as follows. My students variable now, I'm going to propose we think of it as a list. What if we have a list of dictionaries as follows? Indeed, I want to literally implement this picture here. So notice that my previous picture just represented a single dictionary. But suppose I wanted to compose a list of dictionaries. That is, 4 students, so a list of 4 students, and suppose that each of those students is itself a dictionary, a collection of key value pairs, keys and values, something and something else.
Now we're doing dictionaries
Here's one
within
other way we can do
dictionaries.
this in code. Let me go back to VS Code here, and let me define a variable called students that is equal to a list. And I'm going to preemptively move my cursor onto separate lines because I know this is going to be long, and I want to fit all of the elements of this list inside of it. I'm now going to create a dictionary, 1 dictionary per student. And how do I create a dictionary? I just use those curly braces. But it's up to me to define what those keys are. And let me propose that 1 key this time won't be the student's name explicitly. It will literally be the word name, and they're going to have the name Hermione. This same student is going to have another key called house, and the value is going to be Gryffindor. And this same student's going to have a third key called Patronus, and the value of that is going to be, I had to look it up, an otter, according to the book. Now I'm going to create a second dictionary inside of this list. And again, a dictionary is literally like the human dictionary of words. It's a book that contains keys and values, words and definitions. What are the 3 words I'm storing in each of my dictionaries? Name, house, and Patronus. What are the definitions of those words for Hermione, Gryffindor, and otter, respectively? For Harry, the definitions are going to be different in this new dictionary. Let me give myself another pair of curly braces and say this. Name, quote-unquote, Harry. House here is again going to be Gryffindor. And this one I knew, his Patronus is going to be, in this case, a stag. All right, next, a third dictionary. The name here will be Ron. And I'm going to go ahead and do that just like this. Next, I have the house, and he too was Gryffindor. Lastly, how to look this one up, Ron's Patronus was a Jack Russell Terrier. Lastly is Draco in a 4th dictionary now, so another pair of curly braces. The name of this student is, of course, Draco. The house of this student is Slytherin. And Draco, interestingly enough, at least according to the internet, has no Patronus, was never revealed in the books or the movies. So it turns out, this is actually a wonderful teachable moment, there is a special keyword in Python that is literally none, N-O-N-E, with the first letter capitalized. This represents officially the absence of a value. So I could a little sloppily do something like quote unquote, but does that mean I didn't get around to typing it or not? It's a little clearer semantically to say literally none, a special keyword in Python to make clear that I know Draco has no Patronus. It's not just an oversight on my part. Now that I have this, what do I have in the computer's memory? I have a list. How do I know it's a list? Because I see a square bracket at the beginning and another square bracket at the end. That's just my visual clue. Okay, I don't know necessarily what else is going on here, but there's a list of something. What is in that list? Well, here too, the syntax is our clue. Because this line 2 starts with a curly brace and ends with a curly brace, I just know that is a dictionary, a collection of key value pairs. Now, this all fit on my screen perfectly, so I didn't bother moving all of the key value pairs onto new lines. It would have made it really tall, so I kept it all together here this time. But how many keys does this first dictionary have? Put another way, in Hermione's physical dictionary, how many words are in that dictionary? 3. The words are name, house, and Patronus. What are the 3 definitions or values of those words in Hermione's dictionary? Hermione, Gryffindor, and Otter, respectively. And the same story goes for Harry, then for Ron, then for Draco. I have, by design, chosen to give them dictionaries that have all the same keys, all the same names, but they all have unique values. And that's my design. That's my prerogative as a programmer. So why is this useful at the end of the day? Now I have access to a whole collection of interesting data about all of these students, and I can still do a loop. I can say, for student and students, That's going to allow me to iterate over this list of students. And let me go ahead and print out just one thing at a time. Let me print out the current student's name. So as complicated as the dictionary is, this should be pretty comfortable. For student and students is just going to iterate over every student in the list. 1, 2, 3, 4 total. The next line is just going to print out the value of the name key. It's like opening a physical dictionary,
So just going to
looking
do
up the word name, and giving us
Hermione,
Harry,
Harry,
Ron, and
Ron,
Draco,
Draco.
respectively, from each dictionary. So if I run this version of Hogwarts and hit enter, there, I get all 3 of their names. But what if I want more information than that? I want both their names and their houses. Well, just add to print's arguments, student, open bracket, house, close bracket. All right, let's go ahead and run this. Python of Hogwarts.py and hit enter. So I now see Hermione Gryffindor, Harry Gryffindor, and so forth. Well, we can aesthetically clean this up a little bit by adding a separator with print, like a comma and a space, just so that when I run this again, I now see some commas separating these values. But recall that students have not just a name, not just a house, but also that Patronus. So if we want to print out that too, we now have the syntax via which to go into that same dictionary for each student and output their Patronus as well as their house and their name. So if I run this program one final time, now I see all of the data in this here dictionary. So this is a lot to absorb all at once, I'm sure. It's the last of our new data types. On top of lists, we have these dictionaries. But again, a dictionary at the end of the day is just a collection of values similar to these values here that allow you to associate keys with values. And the first version of this program associated literally the students' names with their houses. But then I realized in my next version, wait a minute, what if every student has not just a name and a house, but a Patronus? Let's actually standardize the names of our keys to be name, house, and Patronus, and then the values of those keys can actually be the data, like Hermione, Gryffindor, Otter, and so forth. Questions now on these dictionaries and iteration thereof?
No, actually, this makes a lot more sense than the last section to me.
Suppose the dictionary is very huge, and if I want to look up for a specific student, so how do I know where to look that student from? Like, can we sort it out in alphabetical order or numeric order or anything like that?
In short answer, yes. One of the features of Python is that it makes these dictionaries very highly performant for you. That is, even if they're very large, as they will be in future weeks when we manipulate more data, Python will find the data you care about quickly for you. And in fact, that is a feature of the language, that is a feature of a dictionary to get you the data quickly. And there are functions that you can use. You can sort the data, you can sift through it, you can do very performant operations, as we eventually will. Allow me then to propose, as we wrap up these loops, that we solve just a few final problems that will perhaps evoke fond memories of yesteryear, at least for me, wherein one of my favorite games growing up
Super
was this
Mario.
one here, the original Nintendo. And this is a two-dimensional world.
Great,
where
now we're all going to get
characters move up, down, and
copyright
right,
strike.
not so much to the left, in jumping over pyramids and obstructions like these. And allow me to propose that we use this just for inspiration, not to do something that's quite as colorful or graphical as this, but just to focus on, for instance, this barrier in the middle of the world here that Mario or Luigi had to jump over. And so this here seems to be like 3 bricks stacked on top of one another, and we won't do things quite graphically, but let's just implement a very simple Python-based version of this textually, using maybe just hashes for bricks. Because there's a pattern here, one on top of the other, and I bet we can solve this in any number of ways. Well, let me switch back over to VS Code here, and let me propose that we create a program called Mario.py using code in the terminal window.
All right.
And then up here, let me start.
I don't have to formally protest this. Well, but I do have to get my mouse to work. Alright, so let's do code Mario.py.
By implementing that same picture as simply as I can, printing out just literally the hash, and then the hash, and then a third final hash. This is going to be a very textual approximation of it, but I think if I run Python Mario.py, I've got a very simple version of that same column of bricks, so to speak. But you can imagine that certainly in a game where maybe these the columns get higher or lower, it would be nice to write code that's actually a little more dynamic than that, and doesn't just use print, 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 which is literally copy and paste, it would seem. So let me at least adopt some of today's lessons learned, and instead do something like this. for underscore in range of 3,
Ah.
let's now print out just one of these at a time. But the fact that I've now used a 3 to range means if I want to change it to something bigger or smaller, I change it in one place, not in 3 or more places. And this code 2, of course, if I got it right, is just going to print out the exact same thing. So we're iterating here. But let's see if we can't now integrate our discussion of writing functions of our own to begin writing something a little more dynamic and solving more complicated problems ultimately. One of the nice things about functions is that they allow us to not just write code that we can use and reuse, they allow us to create abstractions, if you will. An abstraction is a simplification of a potentially more complicated idea. And we've seen this a few times over the course of the weeks. For instance, we had a function called hello, which granted didn't do all that much. It just printed hello, but it allowed me to think about the function as exactly what it does. Not generically printing something, but literally saying hello. I've been able to get a number using something similar by defining my own function like getNumber. Well, let me go ahead and, for instance, assume for the moment that I've had the forethought to, in my function main, use a function called printColumn. That seems as good a name as any to use a function that prints a column of bricks. Well, how can I go about now implementing this abstraction, this simple idea, printColumn, with actual code? Well, we've seen before with def, we can do just that. Let me define a function called printColumn. Let me accept as its input, generically speaking, a parameter called height. I could call it n or h, but I'll be a little more explicit now with height, just so I remind myself what it's doing. And now I think I can just borrow some of that same code from before. For underscore in range of height, go ahead and print out a single hash. And then at the end of this whole program, let's just call main. So I've kind of complicated the code. It doesn't do anything more just yet, but it's setting me up for solving what I think are going to be more sophisticated problems. If I run Python of Mario.py, we're back where we began. But I now have a function, an abstraction, printColumn, that's
you
going
can't
to allow me
see.
to think about printing
I'm in the
some
way.
chunk of the world of Mario at a time.
Sorry about
and I can
that.
do this in different ways too. Notice that if I really
It's my
want,
first
I
day.
could do something like this. I could re-implement now printColumn in different ways, especially if I'm using printColumn all over my code, or maybe still a colleague of mine, a friend, someone else on the internet is using my printColumn function. What's also nice about functions you've written is you can change the underlying implementation details of them, but so long as you don't change the name of the function or its parameters or what it returns, if anything, no one else knows the difference. You can change the internal implementation as much as you want if you want to improve it or make fixes over time. So for instance, another way we could implement printColumn, recall, would be something like this. A bit clever with one hash and then a new line, and then maybe we could do multiplication of strings and then end this line with quote unquote. Again, it's okay if you're not comfortable with this syntax. This was a more clever approach we saw in the past, but if I run Python of Mario.py here, I'll still see a column of 3. But what's important here is that main does not need to know that the underlying implementation of printColumn has changed. Well, let's transition to a different dimension, if you will, and rather than print out just these vertical bricks, let's fast forward in the game to this part of the world here. At some part, Mario encounters these bricks in the sky that if he jumps up underneath, they become coins, and so he gains to his score. But let's go ahead and focus only on those coins, and let me propose that we print out, just these 4 question marks here. And let me go back to VS Code here, and let me propose that within VS Code here, just like before, we try to abstract this away.
Print row now?
So let me go ahead and get rid of this version, because we're now going horizontal instead of vertical with our output. And let me just say, well, print row 4 times. Let me just abstract away the problem at hand. I don't know yet how I'm going to print those 4 question marks, but let's call it print row 4, and I'll assume I'll now solve this problem. Let's now go down that rabbit hole of solving the problem. Define a function called print row. It's going to take a width instead of a height, because it's horizontal instead of vertical. And how can I do this? Well, now we have an opportunity to do string multiplication even more elegantly. I can say quote unquote question mark times width. And this is a very pretty Pythonic way of printing what could otherwise be a loop, and that's fine, but this is going to go ahead and print those question marks for me. Let's do Python of Mario.py, enter, and now I've got 4 question marks. It's not nearly as pretty as the more graphical version, but it is at least a building block toward having now a reusable function like print row. And why am I doing all this? Like, why are we over-engineering the solution to these problems by having print column and print row? Well, it's a useful problem-solving technique as soon as your world does not look one-dimensional like this.
Why are we over-engineering it? Come on, we know the answer to that.
Or with the column version, but what about this? Later in Super Mario Brothers, does Mario have to jump down into this world where there's a lot of these underworld barriers? And this one here, for instance, looks like a square. It's two-dimensional. There's a height and a width to it. And that is to say, there's a bunch of different ways we could implement this thing if maybe for discussion it's like a 3x3 grid, a 3x3 square of sorts. Well, how can we go about solving this here problem? Well, let me propose we come back to VS Code and let me propose that we think about this in a couple of different ways. I could do this, like this. If I know where I'm going, you know, maybe I'm a seasoned programmer, let me go ahead and do this. Let me print out a square, the width and the height of which is 3. That's an abstraction. I'm just taking for granted for a moment that there is already a function called print square that's going to be width 3 and height 3 as well. But someone's got to implement this. And at the moment, there's only me at the keyboard, so let's go ahead and implement that square. Let me go ahead and define a function called print square that takes in a specific size, both for height and for width. And here's where we have an opportunity to use some of those loops. And we can use those loops in a way we haven't yet. If I want to print out all of these rows, but also all of these columns, I now have to think not just cyclically, like a loop allows, but I need to think two-dimensionally. And if you're familiar with like an old school typewriter or even a printer nowadays, it generally prints from top to bottom. So even if you have multiple columns, you print out one line at a time, and while you're on that line, the printer or the typewriter prints from left to right. And that's kind of the mental model to have with your black and white terminal window. All of the output for every example thus far starts at the top and goes down to the bottom, from top to bottom, left to right. So we have to generate our output, our square, in that same way. So let me propose that we do this. Let me propose that we know we need to iterate this many times, 3 or more generally size. So let me do this. For I in the range of size, what do I need to do 3 times? Well, I want to print out what? 1, 2, 3 rows of bricks, but within each row of bricks, what do I want to print? 1, 2, 3 bricks specifically. So if we go back to our diagram here, and I stipulate that it's indeed meant to be a 3x3 square, 3 wide and 3 tall, what do I want to do to print the first row? I want to print brick, 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 brick. What do I want to print on the second row? Brick, brick, brick. And the third row, brick, brick, brick. So I'm doing 3 things 3 times. There's a lot of printing that must happen. So let me go back to my code here and let me propose now that we think of this outer loop that I've just started as representing each of our rows. For I in range of size is going to ensure, no matter what I do next, that I can print out 1, 2, 3 rows, or more generally, size, where size could be 3, but it could be smaller or larger. What do I want to do on each of the rows? Well, just like an old school typewriter or printer, on each row, I want to print out brick, 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 brick. Well, that sounds like a cycle, some kind of loop. So maybe I can have inside of one loop another loop. I don't want to use I again because I don't want to use the same variable and mess up my counting. So I'm going to, by convention, use J. Very common to use I and then J, maybe K, but after that, you shouldn't keep nesting inside of each other. Let me go ahead and say for J in range of size 2, because it's a square, and then each of these rows, let me print out a single hash, but no new line. But after each row, let me print only a new line. So there's a lot going on here, especially if you've never touched Python, let alone loops. But notice what I've done here too, and I'll add some comments for clarity. For each row in square, for each brick in row, print brick. And here is where comments, and more generally pseudocode, can really help explain to yourself and to others what your lines of code are doing. On line 8, I'm iterating from I equals 0 on up to size. So 0, 1, 2. On line 11, I'm doing the exact same thing but using J from 0, 1, 2. But that's good because I represents now each of my rows, and while I'm on each of those rows inside of this outer loop, I'm going to do brick, brick, brick. 1, 2, 3, 1, 2, 3, 1, 2, 3. But I don't want my cursor to keep moving to the next line while I'm on a row, so I'm just overriding that line ending. But let me ask a question of the group now. Why on line 16 do I have a print here all by itself? Why do I have a print all by itself? Notice that it's below the inner loop, but inside of the outer loop, so to speak. What is that loop on line 16 doing, ultimately?
Every time you finish a line, you have to add a new line at the end of it. So
Perfect.
it prints a new line.
Perfect. I don't want a new line after every brick. I only want to do that at the end of the row, and that's why my comments now are perhaps enlightening. Notice that this loop here is just...
All right, so hold on. Let me try... So we got the print 3, define print square. So we're defining the print square. The size is 3 for I in range. Print for each row and square. So this is doing the rows. For each row and square for each brick and row. So this is actually what's printing those. For each row. So this is the rows, and then it's just printing it 3 times. I might be lost. I don't know. We'll find out. Because I get how it's printing the rows. So I think the only thing that makes sense to me is that it's reusing this 3 for both 3 rows and 3 hashtags. But I don't quite understand how it knows to do this, I guess, is my thing.
Iterating for each brick in the row. Once I'm done with that inner loop, so to speak, once I'm done with these highlighted lines here, to Evelyn's point, I need to print out one blank new line. And we've not done this before, but when you call print with no arguments, all you get is that automatic line ending, the \n, where the cursor moves to the next line. So if I now go back to my terminal window and run mario.py, I think I should get a 3x3 square. And it doesn't quite look like a square on my screen because these hashes are a little taller than they are wide, but it is in fact 3x3. But let me propose, as we've always done here, how we might tighten up this code further. Just for clarity's sake, let me get rid of my comments for a moment, just so we can see how many lines of code we have total. And let me propose that we maybe do this. Let me propose that, you know what, this inner loop, especially if you're having trouble wrapping your mind around one loop inside of another loop, you don't strictly need it. What if we do this trick again? What if we print out inside of the outer and only loop each of those hashes times the number of times we want them? Right? We draw inspiration from an earlier approach and we run Python now of mario.py, same result, but now print square is really nice and compact. It has one explicit loop, and it's still printing out using string multiplication all of the hashes at once.
Okay, so this is magic. Hold on, I gotta try this. Like, it made sense before. Well, I could see how it made sense before putting the 3x3, because we were telling it 3, so I thought that it was using the 3 for both pound, 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 and then row, row, row. But this one isn't specifying any numbers. Right? Like, there's no 3, there's no nothing. Oops. What did I do wrong there? Define print square size for I in range size print times size main. Why isn't well, maybe he wasn't done yet.
If you like abstraction and you'd like to wrap your mind more around what the code is doing, well, let's do this. If you're not quite clear on what's going on, let's propose that you implement a function called print row, passing in size. And let me propose that this print row function, it simply take in that width and print out the individual hash times that many times. In other words, here's an opportunity for abstraction, whereby...
Oh, okay. He was scrolled down. So that's what I was confused. I'm like, how does it know to do 3? But he just scrolled down. Okay. It wasn't magic. I just missed a part of it.
Well, when you're implementing print square, I don't really care what it means to print a row. I just need to know that someone's taking care of printing the row. You can kind of pass the buck to another function altogether. And how does print row work? Well, it could use a for loop. It could use this string multiplication trick. This is a way to take a larger program, and this is probably the most complicated one we've looked at thus far, and to decompose it into these smaller components that, once assembled, achieve your final idea. Seeing no questions, that's the end of our look at loops in Python, this ability to do things cyclically again and again, and when we combine those with conditionals, this ability to ask and answer questions and combine them with our functions and variables, we really now have most of the building blocks we need to solve much larger, much more interesting, much more personal questions. So in the weeks to come, we'll start to see exactly what could go wrong, though, when we do so, but we'll introduce you to all the more tools via which you can troubleshoot those same problems.
All right. I think, for the most part, I understood that course or that section. I think I understand how, using the 3 that it's getting the 3 by 3 and all that. I think I understand it. I guess time will tell when I do the problem sets. See what this says real quick. I won't actually work on it or anything. Suppose that a machine sells bottles of Coca-Cola 50 cents and only accept coins and denominate. Oh, yeah. Insert coin one at a time. Each time, informing the user in the amount due. At least 50 cents. Put how many cents in change the owner is owed. Assume that the user will only input integers and ignore any integer that isn't an accepted denomination. Fun. So that's like what the actual like problem sets kind of look like. So they kind of take what he kind of went over and then amplified it by 1,000%. So that's fun. So we need to go to week 3. Let me see here. How do I menu? Here we go. So we just did loops. Now we're at exceptions. And of course, it's still not working right. Okay, before we start this, I want to take a little break. Let's take a 15-minute break. Let's come back at 9:45. Be back 9:45 Central. Take a little breakity break. Let the brain simmer down for a minute. You take a break too. You've worked hard. Take a 15-minute break. We'll all be back here. Please like and subscribe and share and all that fun stuff. Like I mentioned earlier, I started hemorrhaging subscribers. This channel is like a rebrand, you could call it, and this content is completely different than what I used to do. So people are leaving in droves, and but that was to be expected. So, yeah, and I'll be back here real soon. Alright, we're back. I'm back. There's only one me. I can't say we're back. Unless you're back too. Alright. Whoa. Was my audio doing something really weird there for a second? Alright, so next video, 44 minutes. If you're just tuning in, consider hitting that like button, subscribe, share, those whole 9 yards. This is a free course through EDX, HarvardX, whatever. There's a link to it down below. Completely free. You get a little certificate when you're done. You could pay some money, get a validated certificate, a fancier certificate. But we're just I'm just going through the videos on stream, doing the work off the stream. I've only done the first week's problem set, but I'll get caught up eventually. Just gonna take some time. So this is the 4th video in the series. Ooh, didn't mean to do that. Let's get started.
This is CS50's Introduction to Programming with Python. My name is David Malin, and this is our week on exceptions. Exceptions in Python, as well as in other programming languages, refer to problems in your code. Indeed, when something is
Whoa, there ain't gonna be no problems in my code. Wow, let's just go and skip this video. Kidding me? We better watch it.
exceptional in your program, it actually doesn't mean it's a good thing. It means something has gone wrong that ideally you will somehow solve. So what are some of the things that can go wrong? So I'm going to go ahead and open up VS Code on my computer here, and in the terminal window, I'm going to go ahead and run code of hello.py. That's going to, of course, open up a brand new tab for me, hello.py, in which I can write my code. And let me go ahead and write some very simple code just to say hello to the world. Let's go ahead and say print, quote, hello, comma, world, and then let me go ahead and I'm forgetting to close that quote. So a mistake that you yourself might have already made or might surely in the future make.
I ain't gonna make that mistake. Come on.
You just missed that one character. Well, let me go ahead and somewhat optimistically go down to my terminal window now and run python of hello.py and hit enter. And that's the first of my errors. My gosh, I've only written one line of code and I seem to have more lines of errors on the screen, but the salient point is this bottommost thing here. Notice where it says syntax error. A syntax error is a problem with the code that you have typed, your syntax. Just like English and other human languages have syntax associated with them, so does my code. And it's not quite correct. Something is awry. I didn't follow the instructions properly, and it does elaborate for me. Unterminated string literal. Now that's a bit arcane. That is a bit of a confusing error message, but unterminated would generally mean that I started something but didn't stop it. I didn't terminate it. String, of course, is a sequence of text like we discussed before, or str in Python, and literal generally refers to something that you literally typed. It's not a variable, it's something like quote unquote, or just quote, hello world. So the fix here, of course, is going to be to go ahead and terminate that string and actually close the quote. And if I now go back down into my terminal window and rerun python of hello.py, now I'm saying hello to the world. So the catch with syntax errors here is that syntax errors are entirely on you to solve. A syntax error is a problem that you've got to go back into your code and fix from the get-go. You can't just kind of hope that it's going to resolve itself.
I mean, the nice thing is it kind of tells you, undetermined string literal, and it kind of shows like what the issue is or could be, or what it thinks it is, I should say. So at least it's not leaving you in the dark. Can you imagine line 1 it's telling me, can you imagine having a million lines of text and then be like just syntax error? Yeah, That would not be good.
Or expect that other parts of your code will catch it for you. Syntax errors just must be fixed. But there's a lot of other types of errors in Python that might be described as runtime errors that happen while your code is running, and it's really up to you to write some additional code defensively to detect when those errors happen, because you don't necessarily know, for instance, what input humans are going to type into your program, and so you better be ready defensively to accommodate things that they type or even mistype. So for instance, let's go back over here to VS Code, and let me propose that we take a look at a new file altogether. I'm going to close hello.py, and I'm going to write code of, say, number.py. So let's play around with some numbers in Python. And the first thing I'm going to go ahead here and do with number.py after opening this new tab is I think I'm going to go ahead and type up a relatively simple program that maybe prompts the user for an integer, like x, and then just prints out what x is. So we're going to start super simple, but again, in starting simple, we'll be able to really see where I've done something wrong. Well, here we go. I'm going to go ahead and say a variable called x is going to get assigned the value of the return value of input, quote unquote, what's x question mark, and I'm going to include a space to move the cursor over a little bit, and then ultimately I'm going to go ahead and, oh wait a minute, if I'm wanting to get an int from the user, recall that I need to do something proactively. I need to actually convert that input to an integer using the int function in Python. So now I'm passing the return value of input as the argument to int, and that will store in x ultimately an integer, not a string that looks like an integer. All right, let me go ahead now and just quite simply print out what this is. I'm going to go ahead and print out, quote unquote, x is x. But I don't want to literally say x is x. I want to plug in the value of x. So maybe the easiest way to do that is to surround it with curly braces. And then if I'm using these curly braces and I want Python to interpolate the value of that variable, that is, substitute what x actually is in between those curly braces, recall that I need to use a format string or an f string by prefixing this whole thing with an f. Now that I've done that, let's go ahead and see what happens. I'm going to go ahead in my terminal window and run python of number.py. I hit enter, and so far so good. All is well. I'm being prompted for x. Let me go ahead and type in a number like 50. All right, that seems to work. Program seems to be correct. Or is it? What could go wrong in this program, even though nothing did just go wrong? But if I run it and run it and run it again, during the running of my program, what could still go wrong, especially if I'm not the human interacting with it, but some other human instead? Any volunteers here for this one? What could go wrong, and in what way is this program not really correct, even though at first glance it seems so?
What is an interpreter? So, when we code in a integrated IDE, we can't code in an interpreter.
So I'm not calling an integer. I'm still having trouble hearing you, but what I think I heard is that if what the user types in is not in fact an integer, I can't just blindly convert it to
I got a
int.
June bug in
if
here.
I'm not putting too many words into your mouth, I think what I should perhaps do here is be a little defensive, and let me see if I can't simulate exactly the problem that could go wrong here. Let me go ahead and run, again, python of number.py. Let me try another number. In fact, when testing your code, generally it's a good idea to test corner cases, maybe numbers that aren't quite as plain as 50 or 49 or 51. Let's choose some numbers that might be a little more interesting, if only mathematically, like 0. All right, 0 seems to work. My code still prints out that x is 0. What might be another
like
corner
-1?
case to consider? Well, let me go ahead and try a negative number. That too is pretty different in spirit
worked.
from 50. -1? Okay, that works too. Well, let me try it one more time. I've tried positive numbers, negative numbers, 0.
Floats.
Let me try something like a cat. So literally, C-A-T, typing in a string that doesn't even look like a number, and yet let's see now what happens when I hit enter. All right, we'll see now
Already did
another
that.
kind of error. It's not a syntax error, because I didn't make a typographical mistake. I didn't forget some piece of syntax. I actually now have an error with one of my values, and it's in a value I didn't even anticipate. The human, me in this case, typed it in long after I wrote the code. So what does this refer to?
So we need to do like a if input is not an integer, it prints like, maybe it asks again until there's an integer. Maybe that's what he's going to do? Question mark.
To a value error. Well, let's see what the explanation is. Invalid literal for int with base 10, quote unquote, cat. Now this too is a bit of a mouthful, and unfortunately in Python and a lot of programming languages, the error messages are written for pretty comfortable programmers. And of course, when you're learning programming for the first time, you might not be so comfortable with the programming language, let alone the error messages. But let's see if we can't glean some insight. So invalid literal. Well, again, a literal is just something that's been typed in, it would seem. For int, what is int exactly? Well, int is the function I'm using to convert the user's input to a corresponding integer. Base 10, that refers to the decimal system, which is the default that Python's using. And it looks like, at the end of the day, what Python really doesn't like is that I passed cat, quote unquote, to the int function. So how do I go about actually fixing this problem? Well, I could just add instructions in my program. Maybe I could add a line of print telling the user more explicitly, be sure to type an integer, or please don't type cat, please don't type strings. Of course, the user might still not oblige, they might not be reading the instructions, so that too is probably not an effective strategy. What we really want to do is write our code with error handling in mind. We want to write lines of code that not only accomplish the problems we care about, but that also handle errors that might unexpectedly happen. And in general, when programming defensively, assume that the users aren't going to be paying attention, or worse, they're malicious. They're trying to crash your program, so we want to handle as many errors as we can. Now, how do we go about doing that in Python? Well, it turns out whether you want to catch a value error or other types of errors as well, though not syntax error, Python actually has this keyword called try, and it's sort of aptly named. If you want to try to do something in Python, you can literally use this keyword, and you can check whether or not something exceptional, something erroneous has happened. So using both try and this other keyword except, can I go and try to do something, except if something goes wrong, I can do something else instead. So let's consider, how can I go about trying to convert the user's input to an int, except if something goes wrong? Well, let me go back to my code here, and let me propose that I now modify this example as follows. Let me go ahead and above my first line of code, I literally write try and a colon, telling Python, try to do the following. I'm going to go ahead and indent my existing lines of codes here by the same number of spaces, 4 in this case, and then I'm going to add one more new line down here that literally says except value error. And notice it's important that I've capitalized the V and I've capitalized the E. These symbols are case sensitive, and this is now an opportunity, after this colon, to tell Python what I want to do in exceptional cases, when the number or the input from the user is not in fact a number. And I'm going to say something plain like print, quote unquote, x is not an integer. I'm at least going to tell the user roughly what the problem actually is. So notice another detail. The indentation is important. Because I have try on line 1 and I've indented lines 2 and 3, those are the 2 lines of code that I'm trying. Except if I see a value error, line 5, because it's indented, is what is going to get executed in cases of those errors. Let me go ahead now back to my terminal window and run Python of number.py, enter, and let's go ahead and type in 50 again. Still seems to work, and of course I'm trying and succeeding. Let me go ahead and try once more, this time though with the word cat, or really anything that's not a decimal number, and now you'll see much more cleanly.
Oh, he already blew it. What's the decimal numbers
deal?
deal?
I, of the user, am going to have no idea how to handle. Now you, the programmer, have anticipated that something exceptional can happen, and you've gone about actually handling the error for the user, giving them an appropriate error message instead. Let me pause here and see, are there any questions now on what we've just done by introducing try and except to handle this value error?
Is value error the only type of error you can get, or are there other types?
Is value error the only thing you can catch? There are other errors as well, and we'll see a few of them today, and there's many, many more, honestly, that if you continue programming in Python, you're going to see a lot of them over the weeks, the months, the years to come, but the technique for handling them is going to be largely the same. Other questions on try, except, or these exceptions more generally?
Yes. Sir, actually, to use the except block, you need to know the type of error, right? Like here you knew it was a value error. What if you can't anticipate this particular type of the error?
A really good question. So I'm being very good about catching, so to speak, the very error that I know might happen. I don't know when it might happen, because it's going to depend on the user, but I know what kind of error will happen from the int function. There is a way in Python where you can say except if anything goes wrong, and you can literally omit value error and just catch everything. The problem with that is that it sometimes hides other bugs in your code because you don't necessarily know what's going wrong. And if you don't necessarily know what's going wrong, how can you possibly handle it correctly? So bad practice. And put another way, it's lazy to do that, to just say, catch everything and I'll deal with it here. So a much better practice would be to figure out what kind of errors could happen and include mention of them explicitly as I've done. Now, with that said, if you read Python's official documentation, as you'll eventually invariably do, it is not great about telling you proactively what kinds of errors can be raised in this way. So it's a bit of contradictory advice. You should do it this way, but it's not always obvious what you should be checking for. But you get better at it with practice. And some of the times the documentation does spell out what could go wrong. Let me turn our attention now back to this and point out that even though this is better code, it is more correct in the sense that I'm not just leaving it to the user to see some really ugly default Python error message that most people are going to have no idea what to do with. I'm at least handling it more elegantly, and I'm printing out x is not an integer, so it's at least more instructive. But this isn't necessarily the best way to implement this code. Why? Well, here too, I'm actually still being a little lazy. So notice that I'm trying to do not one line of code, but 2 lines of code. And this isn't a huge deal because we're only talking about 2 lines of code, but in the interest of preaching best practices, you should really only be trying to do the 1 or very few lines of code that can actually raise an exception, that can actually fail in some way. I am pretty sure that calling print here is not going to raise a value error. Whether x is an int or a string or a float or anything else, the format string feature of Python is going to handle printing it just fine. So really what I'm going to do is this. I'm going to move this line 3 down to the bottom of my code. I no longer need to indent it. I'm just going to execute it at the bottom of my file here. Unfortunately, by doing this, I've done a good thing by now only trying to do the minimal amount of work necessary that might raise the exception, a value error, but I fear I've introduced a new mistake. Well, let's see. What is now incorrect? Let me go ahead and again run Python of number.py, enter. Let me go ahead and do it correctly with 50, and all seems to be well. But again, let's try those corner cases, the zeros, the negative numbers, or in this case, the cat. Let me go ahead and type in CAT again,
so
enter.
To define X.
Now I have a name error. So now it's yet another type of error in my code that I've introduced here. And what does this name error mean? Well, just as a value error refers to that, the value of some variable, the value that someone has typed in is incorrect, name error tends to refer to your code. Like you're doing something with the name of a variable that you shouldn't. And why might that be? Well, let me turn our attention back to the code here and consider, what is it complaining about? Well, the name error is what I see down here, and it's telling me name, quote-unquote, x is not defined. And notice if I look further here, it is mentioning line 6. So I know the problem is with my code on line 6.
You have to define.
And that worked a moment ago.
You have to define x.
And I'm defining x on line 2. But let me ask the group here, why does x not, in fact, exist on line 6? Why is it not defined, even though I'm pretty sure I was intending to define it on line 2?
It's defined in the try statement.
Maybe the scope of the variable is between the try block.
So, good terminology. Scope refers to the portion of code in which a variable exists. That too, though, isn't quite right in Python. That would be true in C, C++, and Java, where indentation or curly braces tend to define the scope of a variable. But again, here in general, and this worked a moment ago, x exists once it's defined on line 2, because remember I printed out x is 50 a little bit ago. Let's try one more hypothesis here.
Just have to define x again.
And why is x somehow still not defined?
Yeah, so is it because it's local variable, meaning that like it doesn't define outside of the scope? Because like what people have mentioned, it prompts the input in try, right? But outside of it, it's undefined.
So still good instincts and good terminology too. There's this notion of local variables, which tend to exist inside of functions, for instance, global variables, which tend to exist in entire files. In this case too, though, that's not quite the case. What's happening here boils down to order of operations. Let me come back to the code here and recall that anytime we've discussed the assignment operator, the single equal sign, that copies a value from the right to the left. But consider for a moment at what point something is going wrong. Well, the input function is probably working just fine because we've used that a lot now to get users' input. It always returns a string or a stir in Python. But what could be going wrong? Well, if I'm passing that string to the int function as its argument, it's probably the int function that's erroring. And indeed, if you think back earlier when we had the value error, it was in fact the int function that did not like quote-unquote cat as input. So this is all to say that this portion of my code, highlighted now to the right of the equal sign, that's the code that's creating a problem. That's the code that was creating a value error. And in this case, we're catching the value error, but because the value error is happening on the right of the equal sign, there's no value being copied to the left. The error is interrupting that whole process. So even though we see x equals ... on line 2, the portion of that line to the left of the equal sign isn't getting evaluated ultimately because the value error is happening too soon. And so when we finally get down to line 6, even though it looked like I was defining on line 2, and I would have defined x on line 2 if all had gone well, we didn't get to the part where the value is copied from right to left because the value error happened first, so this code is just incorrect now. So how do I go about solving something like this? Well, it turns out that there's another feature of the try and except syntax that Python supports, which is that it also supports the keyword else. Now, we've seen else before. If you think back to our discussion of conditionals, we saw if, we saw elif, we saw else, which was kind of this catch-all, what you should do in the event that nothing else is relevant. That's kind of the same intuition here for the try except feature of Python. What you can do is this. You can try to do the following, as I've done, except if this goes wrong. But if nothing goes wrong, else go ahead and do this. So this is one way I can solve this same problem now. No matter what now, Python is going to try to execute line 2. If something goes wrong, it's going to execute lines 3 and 4 to handle that value error. However, if you try and this code succeeds, then there is no exception to handle, so you're then going to execute this line here. So it's a little confusing perhaps in that we're now using else both for conditionals, if, elif, else, and we're also using else with these try except blocks, but that's okay. That's part of the language. That's one of the features. So now if I rerun this code in my terminal window, Python of number.py, let's do something correct, like 50, I see that x is 50. So line 1 is executed. We're trying to do the following. Line 2 is executed because the conversion happened successfully and the number 50 gets copied from right to left. The exception does not happen, so we ignore lines 3 and 4. We jump immediately to line 5 and 6, which prints out the result. By contrast, though, let's do this one last time. Python of number.py, let's type in cat, or again, any other word, and hit enter now. We don't see what x is. Rather, we see, quote-unquote, x is not an integer, which is what's being handled in my except clause. All right, let me pause here, because that's a lot of new syntax, and see here if there's any questions on try, on except, on else, name error, or value error.
Can you please repeat try function?
Repeat the name error. What's the problem with the name error?
Yes.
Yeah, so let's just rewind a couple of lines here before I fix this problem by now getting rid of the else. A moment ago, we had code that looks like this, whereby I was getting a name error, Python of number.py, enter, typing in cat, that looked like this, where name x is not defined, and the problem was on line 6, according to this output in Python. Well, let's think about this now deductively. Let's try a different approach. On line 6, I'm seeing an error that name x is not defined. Okay, Python's already telling me x does not exist at that point. So how could that possibly be? Well, where should x be defined? Well, presumably x is defined on line 2, up here. So what could go wrong? Well, if the user has inputted something that doesn't look like a number, like the word cat, passing cat, the return value of input, as the argument to int, to convert the word to an int makes no sense. You can't convert a cat, C-A-T, to an integer at all. So the int function is raising a value error at that point, and the error is being handled with this code here. But notice, this line 6 is not indented. It's left aligned with the rest of my code, which means no matter what line 6 is going to execute, it's going to execute whether I typed in 50 or I typed in cat. But if I typed in cat, again, X never gets a value, so it's not defined here on line 6. So when I introduced finally the else statement, that makes sure that these things are mutually exclusive. I only execute the else if I tried and succeeded up above. Well, let me propose that we refine this just a little bit further as well and consider how we might improve this example a little bit more. It's a little unfriendly of me to be rejecting the user's input after they fail to provide an integer and just quitting the program, really, right? It'd be more user-friendly if I just prompt or reprompt the user again and again. And in the chat, if you could, what's the feature of Python that you can use if you want to do something again and again and again until such time as the user cooperates and gives you what you're looking for, like a number? So yeah, loop, loop, loop. So a loop is something that happens again and again and again, and maybe we can use that same mechanism, a loop, in order to prompt the user for X, and if they don't give us a number, prompt them again, and if they don't, prompt them again and again and again. We don't need to just quit out of the...
This is what I mentioned earlier I thought he was going to do instead of all of this. I didn't know about all of this. We didn't get to all of this in my intro to scripting class. So...
program so quickly. So let me propose this. Let me propose here that I improve this code by deliberately doing this. Let me induce a infinite loop at the very top of my code with while true. Recall that the while keyword induces a loop, a cycle that behaves like this, and it asks a question, a Boolean expression that needs to evaluate either to true or false. Well, if I want this thing to loop forever, at least initially, we'll just say while true, because true is true, so this has the effect of doing something no matter what forever, unless we break out of it early. Now I'm going to go ahead and do this. I'm going to go ahead and move my try except code indented underneath this loop so that I'm trying to get an X. If I have a value error instead, I print out X is not an integer. But this time, what do I want to do if the user does try and succeed in giving me a number? Well, I can do this. I can just break out of my code here. And down here now, I can use that same line of code from before, an F string that says X is, and then in curly braces, X again. So what's going on here? I think this code now, because I've added the loop, is going to have the effect of trying at least once, maybe a second time, maybe a third time, maybe 500 times until the user finally gives me what I want, which is an integer. And once they do, once there's no value error happening, then I break out of the loop and line 9 executes as I would hope. So let me go ahead and try executing this version.
Very
Python
good,
of number
very
dot
good.
py, enter. What's X? Let me go ahead and type in the easy thing first, 50. X is 50. What just happened in terms of the control flow of this program, the flow of my logic? Well, I first found myself on line 1 inside of a loop. Hopefully I'll get out of this loop. What did I then do? On lines 2 and 3, I tried to get input from the user and convert it to an int. Well, I was a nice guy this time, and I typed in 50, which looks like and is a number, so the int function converted it just fine and stored it from right to left in X. Except value error, there is no value error, because if I typed in a number, there's nothing exceptional happening. This is a boring, good execution of my program. So what happens? I break out of the loop. So again, the else clause is associated with the try, not with the except. And once I'm out of the loop, of course, I'm just printing out what X is. Well, let's try the other scenario that might happen. Python of number.py, enter. What's X? Let's try cat, or any other word. Enter. Ah, this is now a new feature. I'm being informed what I did wrong. X is not an integer, so I'm getting some useful user feedback. But notice again I'm prompted, what's X? Well, let me try typing in dog. X is not an integer. What's X? Let me try bird. Enter. X is not an integer. What's X? And suffice it to say, this will happen now forever if I'm in an infinite loop until I try and succeed, at which point I break out. So let's try again. 50, enter. Now I'm out of the loop, and I'm printing out what X actually is. All right, let me pause here and see if there are any questions. The logic is almost the same, but what is different now is I'm in a loop, and I'm using the keyword break in Python to deliberately break out of the loop when I'm ready to, once the user has cooperated.
Do we really need to break? Can't we just print? Or what keeps us from just printing?
Good question. So let me try that. couldn't I just print? Well, let's see what happens if I do that. Let me move this print line at the end into my loop here, thereby shortening the program. And in general, that's been a good thing. Python of number.py, enter. Let me go ahead and type in 50. Okay, x is 50. What's x? Okay, maybe it's 49. X is 49. Okay, maybe 48. Unfortunately, I think you're laughing. You see it. I never break out of the loop, which maybe that's a feature. Maybe you want this to be your program, but I didn't. I'd eventually like this game to stop, so I need to break out in that way. But I can do it a little differently, and let me propose that we modify this a little bit. But first, any other questions on this syntax here? Let me rewind to the prior version.
Hi, can I use break or in exception except in else? For example, in another print, when you use print in the else, you can use print together with break or something like this?
So you can use break inside of loops to break out of loops, and you can use it inside of a conditional, like an if, an elif, or an else. You can do it inside of a try, except, else statement too. Anytime you're in a loop that you want to break out of, you can use this keyword break. I'm using it in the context of exceptions, but it's not restricted to that. And let me show you too, it doesn't even have to be in the else. If I wanted to, I could actually do this. I could get rid of my else, and I could go back to line 3, add another line that's indented, line 4, and break out here. Now, why is this logically okay? Well, consider what I'm now trying to do. I'm trying to execute line 3 and converting the user's input to an int, and I'm trying to store the result from right to left in X. If something goes wrong, the code we've already seen is immediately going to jump to line 5 and then 6 to handle the exception. But if nothing goes wrong, my code presumably should just keep on executing line by line. So I could technically, logically put the break here and watch what happens when I run this version. Python of number.py, 50, enter. It worked. I broke out of the loop. Now, which way is better? Honestly, I think it could go either way at this point. This program's so relatively short that even though I'm trying to do two things now, one of which, the break, is not going to fail. Like, you either break or you don't. There's no piece of data from the user that's going to influence that. We don't strictly need to have those 2 lines of code there, but it's only 2 lines, so I think it's okay. And if you recall our discussion in the past, not just of correctness, does the code work as it should, but design, I think you could argue it either way. If you prefer the readability of this and the fact that you don't have an else, that's fine. If, though, you prefer to minimize just how many lines of code you're trying to execute in case something goes wrong, the else is a reasonable approach too. Well, allow me to propose too now that we refine this further. I think we're at the point where it's pretty darn correct. But suppose now that I find myself today and tomorrow trying to get numbers from the user quite a bit. It would be nice, as we've seen, to maybe just invent my own function, getInt, to get an integer from the user both today and tomorrow and beyond. And heck, maybe I can even share that function with other people if they want to write programs that get integers from users. So how might I go about doing this? Well, let me go ahead and propose that we do this. Let me get rid of the print line, but keep most of my loop here. Let me define a function called getInt that takes no arguments for now. And I'm going to go ahead and indent all of the code I already wrote underneath getInt. So now I have a function called getInt that tries to do the following. Try to get an int from the user. If something goes wrong and there's a value error, yell at them with x is not an integer. Else, break. But it's not just breaking that I want to do here. Now that I'm in a function, recall our discussion of return values. If you're inventing your own function, whose purpose in life isn't just to print something on the screen like a side effect, but is to hand back a value, to hand you back a value, like on that same post-it note from our discussion of functions, well, you need to return x explicitly. How do I now use this function? Well, as soon as we start making our own functions, it tends to be convenient to define our own main function as well. That's the main part of our program, and I'm going to keep this simple. I'm now going to say x equals getInt, and then on the next line, I'm going to do that print from before, quote unquote, x is, in curly braces, x. And at the very bottom of my program, recall, I'm going to call main, so that no matter what, I'm invoking...
Hold on, you're going way too fast here, buddy.
To return x explicitly. How do I now use this function? Well, as soon as we start making our own functions, it tends to be convenient to define our own main function as well. That's the main part of our program, and I'm going to keep this simple. I'm now going to say x equals getInt, and then on the next line, I'm going to do that print from before, quote unquote, x is, in curly braces, x.
All right, let's print if x is curly braces x. Alright, I think I got all the colons and everything I need.
And at the very bottom of my program, recall, I'm going to call main, so that no matter what, I'm invoking my main function after everything's been defined. Well, let's see how this works. Let me go ahead and run Python of number.py, enter. Let's type in 50, and it seems to work as before. Let's go ahead and run it again, typing in cat, C-A-T this time. X is not an integer, and I'm being prompted. Dog, and I'm being prompted. Bird, and I'm being prompted. Fine, 50. That's an int, and so it is printed. So what's worth noting here, well, I'm manifesting a couple of good properties here. One, I've kind of abstracted away this notion of getting an integer. And even though I just artificially hit enter a whole bunch of times just to hide that function for now, it needs to be there, but we don't need to see it at this point. Notice that now this entire program really boils down to just these 3 lines of code now. Why? Because I've abstracted away that whole process of getting an int from the user into this new function of my own called getInt. But can I improve upon this? Well, let me go ahead and undo all of those blank lines and pull this up just so we can see more on the screen at once. Can I tighten up my implementation of getInt? It is correct. I claim this is correct. It's handling errors and it's returning x, but I don't, strictly speaking, need to write the code as long. What else could I do? Well, let me propose that if all you're doing on this line 13 is breaking, and then immediately after that, per the indentation, you're executing return x on line 14, why are you wasting everyone's time? Once you know you're ready to return the value, you could just return x. And so in my else, I could break out and return a value. So here too, return is used to return values from functions. Break is used to break out of loops. But it turns out that return is sort of stronger than break. It will not only break you out of a loop, it will also return a value for you. So it's doing 2 things for once, if you will. But can I make this even more compact? If my goal is to just tighten the code up, even though it's already correct, can anyone think of a further refinement, whether you've programmed in Python before or not? Can I shorten this implementation further, just a little bit, if only to decrease the probability that I've made a mistake by having fewer lines, and just make it a little easier to read because it's shorter? Any suggestions for tightening up my implementation of getInt?
You can just return the value on the try function when you're trying. You take the input x and then return x.
Good. We can just return x a little higher up. And let me correct folks as we go. It's not a try function. It would be a try statement technically. A function typically has a parenthesis and another one. In this case, it's just a statement. But we can do exactly that. I don't technically need the else. If I really want, I could do this. Right after line 9, I could return x here. Or recall our discussion of defining variables unnecessarily sometimes. Like, why define a variable here if you're immediately going to use it here and then never again? So we could avoid a new line here, and I could avoid even defining x explicitly. I could just say something like this. I could return int input, quote unquote, what's x. I can do it all at once. Now, which is better? I don't know. I mean, again, this is where reasonable people might disagree. I'd argue that on the one hand, we're tightening up the code. We're using fewer lines. It's easier to read, lower probability that I've made a mistake. On the other hand, it's a little more complicated to understand, perhaps. It's a little less obvious where I'm returning from. So I think arguments can be made either way. At the end of the day, what's important is that you've done this consciously. You've made a decision to do it this way or this way, and you can justify it in your mind. Not that your answer is, it worked, so I left it alone. Like, have a good reason. Come up with a good reason, and that will come with experience and practice. Well, let me propose, too, that we make one other refinement here. Suppose that you're finding your programs to be a little noisy, and it's a little obnoxious that you keep telling the user x is not an integer, x is not an integer, x is not an integer. What if you want to make things a little gentler and just prompt the user again with the same words, what's x, what is x, what's x, again and again? Well, you can do that as well. And it turns out that if you want to handle an exception in Python, but you want to pass on doing anything with it, So you want to catch it, but you essentially want to ignore it. You don't want to print anything. You don't want to quit the program. You just want to silently ignore it, like if you're talking in a room full of people and it's your turn to talk and you're just like, pass. They're still calling on you, but you're not doing or saying anything more. Well, we can add this keyword to our code here. Let me go back to my program here, and instead of printing out again and again, x is not an integer, I could just do this. I could pass on handling the error further. I'm still catching it, so the user's not going to see a scary message even mentioning value error. My code is catching it, but I'm passing on saying anything about it. I'm going to stay in the loop, I'm going to stay in the loop and keep prompting and reprompting the user, so now the effect looks a little something like this. Python of number.py, let's type in cat. What's x again? Let's type in dog. What's x again? Type in bird. So it's just a little, maybe more user-friendly in that you're just reminding the user what you want. Maybe it's worse. Maybe it would be helpful to tell the user why you're prompting.
I think it's worse just only because the user obviously doesn't understand that all you want is an integer and it's not telling them that's all you want. So, in my opinion, it's nice to have it say x isn't an integer or whatever. Just, yeah.
Them again and again, it's not obvious, so it could go both ways, but again, it's just another mechanism now for handling these errors. We use the except keyword to catch a specific error, but we don't have to handle it more than that. We can just pass on doing something further. Let me pause here and see if there's any questions now on try, accept, else, or pass.
Okay, yeah, no, I was just kind of curious, I guess, about the idea of when you were indenting with the getInt function, for example. Because I'm noticing, obviously going through it with the whole logic and breakdown of the entire function, while true, do this. But I'm just kind of curious on elaborating with the indentations for the code more.
Yeah, so the indentation is deliberate logically. Some languages don't require as rigorous indentation. You can use curly braces or other symbology to make clear what is associated with what. In general, anytime you indent something in Python on this line, anytime you write a line of code in Python that's here, and the lines below it are somehow indented, that means that those lines are somehow associated with that first line. And presumably, those indented lines should only be executed if the first line told the computer to do so. So concretely, what does this mean? On line 6 here, we're defining a function called getInt that takes no arguments, colon. Everything that's indented by at least 4 spaces hereafter is part of that function. Why? That's just the design of the Python language. Frankly, I think the designers got tired of seeing really ugly code in languages like C and C++ and Java that don't necessarily enforce indentation to this extent. So now it's baked into the language. And my chronology might be a little off there, but there's been many languages that are looser than Python when it comes to indentation. The indentation is meaningful on line 7 too. Notice that because the while true is indented by 4 spaces, that just means it's part of the getInt function. But notice below the while true statement, there's 8, there's 12, there's 8, there's 12 spaces here, and I'm just quickly counting the dots. That means that all of the lines I've just highlighted are inside of that while loop. While true means to execute lines 8 through 11 potentially again and again and again. And now lastly, on line 8, because we have try and indented below it is line 9, that just means that what you should try is what's on line 9. And similarly, on line 10, below it, we have indented line 11. You should only pass when there is an exception of a value error. So the indentation just means what is associated with what. And once you get comfortable with that, you'll see that it helps, the indentation alone helps explain the logic of your program, and it has a wonderful side effect that for yourself the next morning, for your colleagues, your family, your friends, your teachers, your code is much more readable as a result. It's not one big mess of a blob of text. Other questions now on try, accept, else, or pass?
Yeah, thanks. Two questions. Question one, once you say pass, can the caller still learn anything about this error through a system variable or whatever? And question two, problem set 0 referenced some string methods, including is numeric. Is it any different to go via is numeric here?
A good question. So on the first question, if I'm handling the error in this way, the caller is not going to know anything about it. That's the point of my handling it, so that main or other callers don't know that anything technically went wrong. On the second question, is numeric is another function that you can call that can look at a string and determine, is this in fact a number? I could use a mechanism like that. I could use a conditional. If this looks like a number, then pass it to the int function and go ahead and convert it to an integer. That's totally fine. I would generally say that the Pythonic way of doing things is often, for better or for worse, to try things, hope they work, but if they don't, handle the exception. So other languages are more in favor of checking if, elif, else, and all of these conditionals. Python tends to be a little more of the mindset, try it, but just make sure you're handling the error. So this would be the Pythonic way of doing it. Your way, though, checking with a conditional, is it a number first, is totally reasonable too, if you want to go that way. Well, let me propose some final refinements to this program that really just kind of tighten things up one additional step to improve the implementation of this getInt function. Let me propose that we not hard code, so to speak, that is, type manually x all over the place. Let's make this function getInt a little more reusable. Right now, notice that I'm just kind of using the honor system that, well, main is defining a variable called x, and getInt is asking for a variable called x, but it would be nice if the caller, main, doesn't have to know what the callee is naming its variables, and vice versa. So caller, to call a function means to use it. The caller is the function that's using it. The callee is just the function being called. It would be nice if I'm not just hoping that x is the same in both places. So let me propose this. Let me propose that we actually add a parameter to getInt like this. What's x? That is to say, if main wants to use the getInt function, well then main should probably tell the getInt function what prompt to show the user. Just like the input function, recall, that comes with Python, it's up to you to pass in a prompt that the user then sees when the human is asked for input. So how do I make this work here? I can go down to my definition of getInt, and I can say, all right, getInt is going to take a parameter now called prompt. I could call it anything I want, but prompt in English is pretty self-explanatory. It means what do you want, the message the user will see. And now, down here, when I actually use input, I don't have to presumptuously say what's x, because what if the program, the caller, wants to ask for y or z or some other variable? I can just pass to input whatever prompt the caller has provided. So now I'm making more reusable code. It still works just the same. I haven't changed the functionality per se, but now it's a little more dynamic, because now getInt doesn't have to know or care what variable is being asked for, what's being asked for. It just needs to know what prompt it should show to the user. So if I now run this program down here again, prompt number.py, enter, what's x? 50, still seems to work. Let's run it again. Let's type in cat. It still seems to work, and if I type in cat, dog, bird, or anything else, it will keep prompting me with that same prompt, making this code, therefore, all the more usable. Now, it turns out, too, you can even raise exceptions yourself using Python's raise keyword, but more on that another time. So in the coming days, the coming weeks, the coming months, as you write more code in Python, you'll see that errors are inevitable. Sometimes there's syntax errors, which you got to just fix if you even want to run your program at all. But they could be name errors, for instance, variables that you meant to define but somehow didn't. Value errors, where maybe the user didn't cooperate and provided you with something that you weren't expecting, or a whole list of other possible errors or exceptions. But now, hopefully, you know how you can handle these errors and respond to them in any way you like. This, then, was our look at exceptions, and we'll see you next time.
All right, very good. Let's go here. Let's just look at one of the problem sets real quick. Just a little something something. Was that not a problem? That was a short. Let's look at a problem set real quick. Oh, that's a lot of reading. Man, it's gonna make me do math. Oi. I don't know, that doesn't look like a lot of fun. Alright, so we went through another video. And let's go to Ooh, this one's an hour and 17 minutes. Let's take like another 15-minute break. And I don't know if I'll get through this whole video. I kind of want to be done by midnight. But we'll see. See how much time is left at midnight, and then I'll just kind of play it from there. I'll at least take a break at midnight. Hard out. That's when my girlfriend gets off. She'll be getting home, and be nice not being on the stream when she's coming in through the door. So might call it quits right before midnight. We might keep going. Just kind of depends on where we're at. So let's take a 15-minute break. Let's be back at 10:50 Central Time. All right. Go enjoy your break. Please like, subscribe, share, all that fun stuff if you haven't already. And we'll be right back. be right back. Another minute or two. Be right back. All right. Hope everyone enjoyed your time away. Please like, subscribe, all that jazz if you're new to this. You're just tuning in. We're learning some Python. Doing a long sesh tonight. Hopefully we'll get done through the excuse me. It's been a long evening. Gonna try get through this one. Be taking another break at midnight or ending at midnight, either or. We'll see how far we can get along. You know, if we got another 10 or 15 minutes at midnight, we'll probably just push on through. If it's like half hour at midnight, I'm probably calling it a night and then starting back up tomorrow at some point. Not sure exactly when. At least at our normal time, 8 p.m. If not way earlier, or maybe even a couple streams. I don't know. I don't know what tomorrow has in store. So enough rambling. Let's get going. Seems loud.
Alright, this is CS50's Introduction to Programming with Python. My name is David Malin, and this is our week on libraries. So libraries are generally files of code that other people have written that you can use in your own programs, or a library is code that you've written that you can use in your own program, but maybe not just this program, but another and another as well. So Python supports exactly this idea, this ability to share code with others, share code across your own projects, and it does so by way of what it calls module. A module in Python is just a library that typically has one or more functions or other features built into it. Generally, the purpose of a library...
I don't remember modules at all. I don't know. I don't think we ever got to modules, to be honest.
Or a module specifically, is to encourage reusability of code. If you find yourself using the same types of functions again and again, the same functionality, if you find yourself copying and pasting from an old project into your new project, odds are there's an opportunity there to factor out that code that you keep copying and pasting, that you keep reusing, and put it into a library that you can then load into your programs moving forward, so as to not just copy and paste it and have all these different copies all over. So what are some of the modules or libraries that Python comes with? Well, Python comes with a random library, literally, which is to say that when you install the Python interpreter on your Mac or PC or somewhere in the cloud, not only do you get Python, you get a whole bunch of modules as well. Now, these modules provide you with functions that you don't have access to just by default, like you do print and input. Print and input and other such functions just work in Python. But sometimes functions are tucked away in these modules, so you have to be more deliberate about loading them into the computer's memory. So somewhere on the computer's hard drive, once you've installed Python, there is also, it turns out, a file probably called random.py that someone else wrote, probably long ago, but that you have access to. And in that random.py file, there's probably one or more functions that you yourself can use in order to do things randomly. That is to say, how could you flip a coin in a program in Python? How could you pick a random number between 1 and 10 in Python? Well, you need a bit of randomness. And while you could figure out mathematically how to write functions like that yourself, it's a lot easier to stand on the shoulders of others who've already solved that problem for you, so you can focus on the problem.
Yep, let others do the work. Like ChatGPT.
You yourself want to solve.
Just kidding. No vibe coding here. Honestly, though, let's be real. I don't see myself doing a lot of coding or programming or whatever you want to call this in my day-to-day life. So I'd probably, like if I get a job somewhere and I'm doing something and I need to automate something or whatever, I'm probably going to start off with AI. Let's be real. I'm probably not going to build something from scratch if I can get 90% of the way there. But I still think it's important to understand what it's doing, and that's the whole point of this.
So for documentation on most any Python module, you go to the official Python docs and you go to a URL like this where the documentation for that specific module lives. And within the documentation, you'll see a list of the functions or other functionality that some module provides. But how do you go about loading a module into your own program so that you can use the functions in that module? Well, we need a new keyword in Python, and namely...
We did do some importing. I just didn't know it as modules or whatever the random thing.
It's import. The import keyword in Python allows you to import the contents of, the functions from, some module in Python. Well, how might I go about using this in practice? Well, let me propose that there exists in that random module this function, among others. So I have copied and pasted from the documentation this summary of a function called choice. Now, the function exists in the random module, so to speak, not a random module, the random module. And so generally the documentation describes it fully like this. Random.choice is how you would technically call this function, though we'll see alternatives to that. In parentheses, there is a parameter called
I just realized, am I saving all this stuff in PowerShell somewhere? We'll have to... all these little Python files I'm doing, is it a temporary thing? I wonder if it... Do I need to go in there and find all these little files in PowerShell or something? Or maybe it... I don't know. To be honest, I don't really understand how PowerShell works. To me, it just looks like a just regular command line. So I don't know.
CQ for sequence, and sequence generally means a list or something that is list-like, if you have a list of numbers or strings or anything else, and the documentation elaborates. Well, how can I go about using this function to solve perhaps a familiar problem? Well, let me go ahead and open up VS Code here, and let me propose that we implement a program that simulates flipping a coin that in the US heads heads or tails, the idea of which is to pick a decision with 50-50 probability, 50% probability of heads, 50% probability of tails, or you can use some other mechanism like that. Well, let me go ahead and open a program with code called generate.py, because I want to start generating a whole bunch of random information, the first of which is just going to be a coin toss. Now, how do I go about using that function? Well, I first have to import the random library. So literally the first, or among the first lines of my file, should be import random. And that just gives me access to all of the functions in that specific module. Now suppose I want to flip a coin. Well, I can do random.choice per the documentation a moment ago, and that again takes a sequence. What's a sequence? It's a list or something that's list-like, and we know about lists. We've used lists to iterate over numbers. We've used lists to iterate over students at Hogwarts. Let's go ahead now and iterate over just a list of two sides of a coin. Heads, quote-unquote, or tails. Now I could call these anything I want. These are my strings. I just want to simulate a tossing a coin, so I'm just going to say in all lowercase, heads and tails. But notice the syntax. I have heads and tails in double quotes. That's because they're strings. I could also use single quotes so long as I'm consistent. There's a comma between them, which means the list has two elements. There's square brackets to the right and the left, which indicates that this is indeed a
Doesn't do
list.
anything.
That's the syntax
We
recall for
didn't do
defining
anything
a
else.
list in Python.
I don't know why I
And then
hit
lastly, there's
run
something
there.
more familiar. There's the parentheses. Outside of those square brackets,
I'm getting
those are just
tired.
the parentheses that
That's
belong
why.
to the choice function and specify where its parameter gets passed in. But again, unlike past functions, I have to specify what module this function is in, at least for now, and so I do random.choice to call this specific function. All right, well, it's one thing to flip a coin, picking between those with 50% probability, and that's what random.choice does. It takes in a list, and it returns to one of those values randomly with equal probability. Because I've passed in 2 items, I've got a 50-50 chance. If I passed in 3 items, it'd be a 33% chance for each of those items, and so forth. Python does the math for you. But I want to store the value of this in a variable, so let's define a variable called coin equals whatever the return value is. So this is indeed like flipping a coin. I'm going to store in a variable called coin whatever that value is, heads or tails. And now, just so I can see what's going on, let's go ahead and print out the value of that string coin. All right, let me go ahead now and run this program in my terminal window. Python of generate.py, enter, and it looks like the first coin toss was the heads. Let's go ahead and run it again, and it looks like it was heads again. Maybe you want to chime into the chat here. If I run it a third time, what's it going to be this time?
Heads.
You want to type your thoughts in the chat?
Because it was heads.
You might think there's a bug here, but this is probability in action. If I go ahead and hit enter a third time, there, it's actually now tails. And again, 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 heads. Now, if we did this an infinite number of times, it would indeed work out to be 50-50. If we only do it a few times, it might not work out as cleanly. But that's how probabilities indeed work. All right, so I've got that now working. Could I have implemented this in a different way? Well, let me show you an alternative to actually using the import keyword alone, and let me introduce the keyword from in Python. So from is a keyword in Python that you can use when importing functions from a module, but it allows you to be a little more specific than import alone. So if I go back to my code here, it's worth noting that what technically I'm doing here by importing random is I'm technically importing everything that's in that module. So not just the function called random.choice, but a few other functions as well. So instead of using this line of code at the top of my file, import random, which will technically give me access to all of the contents therein, a downside of that is that I have to type in random.choice, random.this, random.that, because all of the functions I'm calling have to be associated with the scope of that module. Well, suppose that I just want to call the function as its name, choice, I can do that as well. Let me replace this first line here with from random import choice, and what this does effectively is it loads the function's name, choice, into my current namespace, into the scope of the file I'm working in. What that means is that I now no longer
Don't need
have
this
to specify
anymore.
which choice function I mean. I can just say choice, and so it loads it into the local namespace, that is, into my local vocabulary, if you will, so I can just now say choice. This might be advantageous in what cases, do you think? When might you want to import the name of the function explicitly like this, as opposed to just saying random.choice throughout your code when calling a function?
No idea.
Any instincts here for this alternative import using from?
Hello, I'm Mohammed Omar from Egypt. Maybe if we have a variable that its name is basically like choice, if I have a variable called the choice, so I need to differentiate which choice I choose, so I'm gonna choose random.choice.
Yeah, really good instincts. By using the first approach, by just importing random, you're making sure that all of its contents are associated with, are scoped to the random module, so that you can have your own choice function. You can have your own choice variable. You can use the same names as all of the functions or variables that are stored inside of that file without them colliding, so to speak. And this is a good thing. In older languages, it was the case that if you imported someone's library, you better hope that you're not using the same functions or variables as they are,
That
because
makes
you might in fact
sense.
have some kind of conflict. Python and certain other languages allow you to scope the names of those functions and variables to the file or the module that they come from, so that's a good thing. But honestly, this is such a short program, or equivalently, maybe I'm using the choice function in so many places, calling random.choice, random.choice, random.choice. It's just making my code longer and longer and longer. Marginally so, but and it's just getting ugly and annoying. I can simply import choice and now tighten up my code a little bit. So as with so many decisions in the past, there's not necessarily one right approach or another. It depends, but I think for those very reasons, sometimes it's better to do what we did the first time, which is only import the module so as to retain the scope therein. Well, let me propose that we transition to another function that comes with Python's random module, and that's this here from the documentation, randint. It's a bit hard to say, but it implies get back a random int, and if you read the documentation, it's a random int that's between A and B inclusive. So if you were to pass in 1 for A and 10 for B, you would get back a number between 1 and 10 inclusive, including the 1 and including the 10 potentially, each with a 10% probability. So how might I go about using a program like this? Well, let me come back to my generate.py file, and why don't we go ahead and try generating a random number between 1 and 10. You might do this frequently in the real world when you just want someone to pick a random number. You tell them as much and the human responds. Let's get the computer to do the same here. Let me go ahead and delete my 2 lines of code at the bottom, but keep my import random. And let's go ahead and define a variable, this time called number. Set it equal to the return value of random.randint, and now pass in A, a value of 1, and B, a value of 10. And now let's go ahead and print the number. I'm going to go ahead in my terminal window and run Python of generate.py and hit enter. 4.
8.
Python of generate.py and hit enter.
1.
8. Again.
9.
Again.
4.
7.
4.
Again. 10.
5.
Again.
6.
2. Again.
7.
And we can do this all day long, and if we add all
we're
those
not
up, they should
we gotta
end
keep
up
doing it
being
till we match.
10% probability each.
Come on now.
Now, how might you use this information? Well, maybe we're playing a guessing game, or maybe we're trying to randomize
Okay, got 5.
the
We
behavior of some
matched.
character in the game. You can imagine using very simple building blocks like this, just kind of spicing up your program by getting it to do things a little less predictably because you're choosing these values seemingly randomly. And you're deferring to Python to actually do the generation of these numbers using its own algorithms and its own math. Well, what more could we do here? Let me propose that we introduce another function that comes from this random library, yet another that you yourself don't have to implement, shuffle. If you read the documentation for shuffle in the same random module, you'll see that it takes in a list, for instance, of values and just shuffles them up. It randomizes them. Like a deck of cards here, you might shuffle them so as to put them into seemingly random order. Well, how do I use this based on this function's name? Well, let me propose that we go back to VS Code here, and let me go ahead and this time do the following. Because I need to shuffle something like a deck of cards, let me go ahead and not just import random, but let me give myself a variable called cards that's going to be of type list. And just so I have something to shuffle, I don't need all 52 cards in a typical deck, I'm just going to shuffle 3 cards, a jack, a queen, and a king. I could call those strings anything I want, but I just wanted a list of some values so as to shuffle them up, that is, randomize the order therein. Well, how does this now work? If you read the documentation for random.shuffle, you'll see that it shuffles the argument in place. That is, unlike many of the functions we've seen, it doesn't return to you a value that contains the shuffled cards in this case. It actually shuffles the list it's given itself. So what this means for my code is that I need to do something like this. Random.shuffle and pass in the variable containing those cards. And then on a final line here, how might I go about printing the cards? Well, I could do this, and I could say print cards, but if I do that, I'm actually going to see Python syntax for lists, and it's just going to format it in its own way using commas and the like. I want to print these cards out one at a time just because I think it'll look a little better. So we can use some of our syntax from loops and say something like this. For card in cards, go ahead and print out the current card. So what's now happening here? Line 3, I'm defining a list of 3 cards in this order. Jack, Queen, King. I'm then shuffling those same cards on line 4. And then on line 5, I'm using a for loop. For each of the cards in that list, print it out one at a time. And because I'm using print, one line at a time.
All of them.
Well, let's see the results. Down here in my terminal window, I'm going to run Python of generate.py and hit enter. Queen, King, Jack. Seemingly shuffled because that's not the order I defined earlier. Let's do it again. Queen, King, Jack. Okay, that happens to be the same, but let's see. This could just be bad chance. There we go. Jack, Queen, King. Doesn't look like it's shuffled, but
I thought
at
it
least
was
we're
just
getting back different
wanting
orderings now.
to do one
Again,
card,
Jack,
not all
Queen,
3.
King. Not so good. Jack, Queen, King. Not so good. This is someone you probably want to play against with cards. queen, jack, king, there we go. But of course, we only have 3 cards here, so there's not that many permutations we might see. And if we do this over time, we will see all of them. But if we had, of course, 13 or 52 cards, we'd see a lot more permutations instead. So we have now these 3 ways to generate random information. One is simple coin toss if you want to start some kind of athletic event. One, pick a number between 1 and 10 if you want to decide something based on that. And now using shuffle, we can even take in a list of things and shuffle them about so that we get some kind of random behavior. Well, let me pause here and see if there's any questions yet on random, on modules, or any of these
I just
want
to print one card.
Yeah. Can we increase or decrease the probability of cards if you want to? For example, there is a 33% chance of probability. So is there any chance to increase or decrease the probability?
Can you set these probabilities, not using these
I
same
couldn't
functions?
understand. Dang
Can
thing
you set
that
the
person
probabilities,
said.
but you can absolutely implement some of your own functions or use more sophisticated functions that do exist in this library and others to exercise more control. These are meant to be very user-friendly and simple functions, certainly the ones we looked at that give you equal probability for all of those, but absolutely you could skew things, though hopefully if you're implementing a gambling game or the like, you're not actually making some cards more probable than others. Allow me to turn back now to our implementation here of this randomness and consider how we might leverage other types of functionality that aren't necessarily in this specific library here. Well, it turns out that Python also comes with a statistics library, and this contains all sorts of functions for doing things more statistical in nature, namely calculating means or medians or modes or other aspects of a data set that you might want to analyze. So how might we use the statistics module in Python? Well, we might first just take a look at its documentation like any other module in Python, and we'll see within that library.
So story time. Statistics class in school, since I was an IT student, our statistics stuff was based in Python. Whereas, like, if you're not an IT student, it's, like, based in Excel. And, true story, I don't know if it was this way for all the students, but for me, so basically, the code was already done. You just had to plug in the statistics. And it had to do with basketball, and you had to pick a couple basketball teams and then compare whatever, the wins, losses, points, I don't remember what. But mine was broken. It did not work. So I had to fix the code just to get it to run, and then hope that I fixed it in a way that it didn't jack up my statistics. So, which I guess I did. I don't know, or if I didn't, the teacher didn't notice either. So, yeah, that was fun. I didn't expect to have to code, and especially code something that was like above what I had learned in the intro to scripting class. It sucked. That class sucked as it was, but really sucked when it was broken and I had to fix it first.
That there's a whole bunch of functions. And one of those functions is one that's quite simple. It's average, a function that allows you to calculate the average of some numbers that you've passed in. Let me go ahead and in VS Code in my terminal window, open up a new file called average.py, and at the top of this file, I'm going to import a different library this time, namely the statistics module in Python. And now I'm going to go ahead and call a function that I know comes in that module, namely mean, for the average of some values, and I'm going to call statistics.mean. And I'm going to pass into this function mean a list of some values. And let's suppose that I'm quickly trying to calculate what my current grade average is in school, and I did really well on my first test and I got 100%, and on my second I did well but not as well and I got a 90. And ironically, I'm not very good with math, so I'd like to figure out what my average now is between those two tests. So let me go ahead now and in this list type in the number 100, 90, thereby passing in a list of two values, two ints, 100 and 90, and outside of those are the parentheses, because of course this is now the argument I'm passing to the function called mean, and this function mean is in the module called statistics. Well, it's not that interesting to just calculate the mean if I don't actually see what it is, so let me additionally pass the return value of that mean function to the print function as usual. Let me now in my terminal window in VS Code type in Python of average.py and hit enter, and voila, as you might
Bam.
expect, my average is 95%.
Worked.
So the difference here is that I'm just using a different module that still comes with Python, but I need to import it instead of, for instance, the random module instead, and this time I know from the documentation that there exists a function called mean. Well, it turns out there's even more functionality that comes with Python and that comes with other modules in Python, and there's this feature generally known as command line arguments. This is a feature not just of Python, but of languages more generally that allow you to provide input not when prompted inside of a program, as happens whenever we call the Python function input, but rather there's this feature, command line arguments of programs, that allows you to provide arguments, that is input to the program, of just when you're executing it at the command line. So up until now, for instance, recall that we've generally run Python of something.py, for instance, Python of hello.py. And I've never once really executed any words or phrases after the name of the file, but I could. In fact, when you're running programs in a command line environment like we are, you can provide any number of words or numbers or phrases after the command that you're typing, and all of those will somehow be passed in as inputs to the program itself. You don't have to prompt the user for one thing at a time by manually calling that input function. So what does this mean in real terms? Well, let me go ahead back into VS Code here, and let me propose that we consider how we might leverage a certain module. I'm going to go ahead and create a file called name.py, and I'd like to use a new module this time that's going to give me access to values that have been typed at that command line. But what's this module going to be? Well, this one's going to be called sys. And sys, short for system, contains a whole lot of functionality that's specific to the system itself and the commands that you and I are typing. The documentation for this module is at this URL here, and it lists all of the various functions and variables and the like that come with that module, but we're going to focus on something a little more specific, namely this thing here. It turns out in the sys module in Python, there is a variable that just magically exists for you called argv. It stands for argument vector, which is a fancy way of describing the list of all of the words that the human typed in at their prompt before they hit enter. All of those are seemingly magically provided to you via Python in a variable called sys.argv. This variable is a list, which means that the first element is going to be the first word that you typed, the second element is going to be the second word that you typed, and so forth. And by way of this list then, can you figure out what words did the human actually type at the prompt and maybe use that to influence the behavior of your own program. So what does this mean now in real terms? Well, in this new tab called name.py, let me go ahead and import sys. Within that sys module is going to give me access to sys.argv, but how might I want to use it? Well, let's do this. Instead of writing a hello world program that all of these times has just looked for the return value of input to figure out what the user wants me to print, let's go ahead and just expect the user to tell us when they run the Python program itself what their name is. And suppose this time I'd like to generate a whole bunch of name tags, initially just one, and in the US here it's very common to wear a sticker on your lapel that says, hello, my name is David, so I want to print out some text that resembles that. The idea being maybe I could enhance this program someday to even send that text straight to the printer and dynamically generate those name tags. Well, let me go ahead now and do this. Let me go ahead and print out, as always, hello, but I'll say a little something more this time to make things more interesting. Hello, my name is, quote unquote. And then
Slim Shady.
after that, I normally have been in the habit of calling input, storing the return value in a variable, and passing in the name of that variable here. But I'm going to instead jump right to this, sys.argv_1. And that's it. I'm going to have a program here that says, hello, my name is, followed by whatever is in sys.argv_1. And notice sys.argv again is a list. And recall from our discussion of loops and intern lists, we use this square bracket notation to get at the various elements inside of a list. All right, let me go down now into my terminal window and run Python of name.py, but this time, rather than just hit enter and wait for the program to prompt me for my name, let me proactively just tell this program what my name is at the so-called command line. Here we go, DAVID separated with a space from the name of the file. so that now when I execute Python name.py David, I see on the screen, voila, hello, my name is David. So based on this demonstration alone, I think we can infer exactly what's going on in sys.argv, even though it sounds certainly, at first glance, rather complicated here. Let's look up. At sys.argv, I'm going to bracket 1 here. So clearly, sys.argv, bracket 1, is storing DAVID, but it's 1. In the past, when we looked at loops, recall that we said that they were 0 indexed. That is, the first element is 0, the next element is 1, the next element is 2, and so forth. And yet here I am treating it as though my name is at the start of the list 1. Well, let me ask this question. What is probably in sys.argv of 0? What is probably in sys.argv of 0?
The file name, maybe?
The very first element actually in that list.
Oh, yeah. I think it's like in C, the name of program.
Indeed, it's indeed, like in C and other languages, the name of the program. Well, if we consider what it was I typed, I certainly typed Python, because that's the name of my interpreter, and we don't really need to know that because we're using Python itself. But after that, I did type 2 things. I typed name.py, as I've done so many times, anytime I want Python to interpret a program I've written, and it turns out by convention, what Python does is it stores in sys.argv the name of the file that you're executing or interpreting, followed by any number of other words that you typed. So all this time, we could have been accessing the name of the program, which frankly isn't all that interesting, but we can also now access words that are typed after that prompt as well. But of course, if I don't type anything in, what might happen here? This might be naive of me to assume that there's always going to be something at location 1 in sys.argv.
Syntax error.
Let me go ahead and try this. Python, name.py, and no, I'm not giving you my name because at this point I might not even know
index
that you
error,
want my name to be typed. So let me hit enter now, and we see now an error. A so-called exception in Python. This one's a new one. This one's an index
We'll just pass
error
it.
that
It'll be
elaborates
alright.
list index out of range. And turns out this is actually one of the most common mistakes in programming, whether using a list in Python or arrays or vectors in other languages, is to try to access some element that does not exist. You try to go too far to the left, or you try to go too far to the right in this object that is just a list of some values. So of course, the mistake here is that I'm assuming there's going to be something at location 1 when really it's location 0 that's the only one that has a value. But fixing this is not going to amount to doing bracket 0, because now if I go ahead and rerun this program with no other words after name.py, it says, hello, my name is name.py, which is fine if we're making a name tag for the program, but that's not, of course, what my goal here is instead. So if the fix is not just to change the 1 to a 0, how else might I handle this error?
Pass it.
How else might I handle this error? This index error that happens if the user just doesn't remember to or doesn't know to type their actual name at the prompt.
We could always put an exception into this program, say, if there's nothing at location 1, we just come out to say, well, okay, we haven't got a parameter or something. But if there is, you continue along with the program.
Perfect. So if I might simplify, we can try to execute this line of code, except if there's an error, we'll deal with it in some other way. Now, ideally, and once I'm a strong enough programmer, I would have anticipated this and written the following code from the get-go, but when you're learning, it's certainly reasonable to see an error, oh, I didn't realize I should detect that, and then go back and improve your code. But of course, if you read the documentation, you ingrain some of the lessons learned from the past, you'll get into the habit of trying and checking for some of these exceptions yourself. So let me solve this in one possible way, as you proposed here. Let's try to handle this exception as follows. Let me go ahead now, and instead of just blindly calling this print line, let me try to print out, hello, my name is such and such, except if there is an issue, specifically an index error, then what do I want to go ahead and do? I'm going to say something like too few arguments. I could be more explanatory than that, but for now I'm just going to explain to the user that they gave me too few arguments, too few words at the prompt. So now it's still not going to work in quite the way I want. I'm still not going to be able to generate their name tag, but at least they're not going to see some cryptic error message and think that they themselves broke the program. Let me go ahead now and run python of name.py, enter, and too few arguments. Okay, let me go ahead now and do python of name.py and type in my name, David, and now we're back in business, and I see that my name is on the screen too. But strictly speaking, I don't have to try to do this. I could actually be a little more defensive in writing this code, and maybe I could check whether or not the user has indeed provided a name or multiple names at the prompt, so as to give them more refined error messages as well. So how might I do this? Well, let me go and undo the exception handling I've added, and why don't I instead more modestly try to do this? Let me go ahead and introduce a conditional here. If the length of sys.argv is less than 2, or equivalently equal to just one value, but I'll just stick with less than 2 for now, then go ahead and print out too few arguments. So I want ultimately 2 arguments. I want the name of the program at location 0, and I want the name of the human at location 1. So that's a total of 2 arguments. So if I have fewer than 2 arguments, let's tell the user with this print line, if the length of sys.argv is, say, greater than 2, like they typed in too many words at the prompt, well, let's tell them, print, quote unquote, too many arguments, else, if they did get it right, and they gave me exactly 2 arguments, else, let's go ahead and print what I actually care about. All right, let me go down to my terminal window here and run python of name.py, and voila, a completely different type of error. This one, a syntax error, which we've seen in the past. Now, a syntax error, recall, is mea culpa, like I messed up here and I wrote invalid syntax, and so no amount of conditionals or exception handling is really going to catch this one. I need to go back and just get my program to work because it's not running at all. Well, let me go up here and see. Line 4 is the issue, and indeed it looks like I have an unterminated string here. I need to go ahead and now add this double quote. So let me go ahead now, and with that red herring gone, let me rerun python of name.py and hit enter, and now we see too few arguments. Okay, maybe it wants my full name. Let me go ahead now and run python of name.py, David Malin, typing in both words after the name of the file and hit enter. And now, of course, it's too many arguments. Fine, now I'll oblige and do python of name.py and just David, and there we have it, my name tag printed on the screen. So strictly speaking, we don't have to handle exceptions if we can be a little smarter about it.
I don't know why you would
just
do
check for the
this.
things
That's
that we're
the only
worried
thing I'm
about,
confused.
especially if we want to
Like,
give the
what-
user more refined advice.
What
We
are
don't
we
want to just tell
doing that
them,
we
no,
need to
something
know
went wrong, or
that
don't
we
want to
use
pass.
this?
We want to tell them, no, that's too few. Or
What
no,
real
that's too
world
many.
example?
We have conditionals in our vocabulary already, via which we can now express that. Well, let me pause here and see if there's any questions now on how we handled the error before with the index error, or how now we're just proactively avoiding all index errors altogether by just checking first, is it too few, is it too many, or is it exactly what we want?
Oh yeah, thank you. So I was wondering, you touched upon kind of using your full name. Could we then is there a way going forwards that perhaps we have people that want their full names and want just their first name, that we separate that into like, oh, this person has full name, this person has just the one name?
Absolutely, and allow me to propose we come back to that support for multiple names, but indeed we could do that. And I should note too, though, we can support full names right now if I do this. Instead of typing in David space Malin, which is problematic because, again, by definition of how argv works, each word ends up in a specific location in the list. But if I add quotes, single quotes or double quotes at the command line, now Python will view this as 2 total things, the name of the file and this full name. And now when I hit enter, I don't see the quotes. The whole thing is passed in as my full name. And if I want to adapt this further for multiple people, we'll be able to do that as well. Other questions now on this version with if, else, or on except before?
Hi sir, I want to ask you, can we use multiple else statement?
Can you use multiple else's statements? No. Else is the last catch-all statement that you can have. You can have multiple if statements in the middle, but not multiple else's. All right, well, let's turn our attention back now to this code and see if we can't refine it a bit more by adding in some additional functionality that we get with modules like the sys module. One of the things I don't love about this version of the code, even though arguably it is now correct, is that the essence of my program, which is just to print out the name tag, is kind of relegated to this else clause. And that's fine. Logically, it's correct. But generally speaking, there's something nice about keeping all of your error handling separate from the code that you really care about. Having all of these ifs, elifs perhaps at the top of your code that are checking to make sure that all of the data is as expected. But then it would be nice, if only for design's sake, not to sort of hide in this else statement the actual code that you care about. I would prefer, for instance, to do something logically like this. I could check for errors up top, and then down here, print the name tags. It would be nice if those are sort of distinct blocks of code, all of which are here left aligned. But there's a problem with what I've just done here. Logically, what bug did I just introduce by getting rid of the else and introducing line 10 on its own with no indentation outside of the conditional? What bug have I just introduced? What mistake, to be clear?
Name error.
Ironically, it's a name error, but not a name error exception. It's an error with my name, but I think you're frozen for me. It's going to raise an exception because even though I'm checking the length of sys.argv up top, and even though I'm checking it again for being greater than 2, not just less than 2, but greater, I'm still then blindly and incorrectly assuming it's now going to exist. So just to be clear, if I run python of name.py and I don't type any arguments, I've got too few, I think I'm going to see that I have too few, but I'm also going to see that same exception. At the very top of my terminal window's output, there's my error message, too few arguments. But again, on line 10, I blindly proceed to still index into my list at location 1, which does not exist. So it turns out there's a better way to handle errors like this, especially if you're writing a program in Python that's just meant to run briefly and then exit anyway. But maybe we could start to exit prematurely if the program itself just can't proceed. If the user has not given us the data we want, perhaps we should just exit the program earlier than we might otherwise. So let me go ahead and do this. Let me go ahead and remove my comments so as to focus only on the code here. And let me propose that instead of just printing quote-unquote too few arguments, I'm going to use one other function that comes with the sys module. I'm going to go ahead and call sys.exit. And as the name suggests, it's going to do exactly that. With the system's help, it's going to exit my program then and there on line 4. Why is that okay? Well, if you gave me too few arguments, I have nothing more to say to you, the user. I might as well exit a bit prematurely. And I can do this as well on line 6. Let's go ahead and not just print that, but sys.exit, quote-unquote, too many arguments. Print out that message and just exit right there. Now I can trust that by the time I get to line 8, every error condition has been checked for, and so it's safe for me to assume that there is, in fact,
an item
at location 1 in sys.argv. So let me go ahead now and run this. Python of name.py, enter, too few arguments, but I'm back at my prompt. Nothing more has happened. Let me run it again. Python of name.py, David Malin with no quotes, enter. Too many arguments is now printed here. Finally, Python of name.py, just David, enter. Hello, my name is David. So we have then in sys 2 forms of functionality now. We have access to this variable, sys.argv, this argument vector that gives me all of the words that were typed at the prompt, including the program's own file name. And it turns out, if we read further in the documentation, there's an exit function that can take different types of inputs, but if I pass it a string like this, it will indeed print that string for me and then exit from my program then and there. Questions now on exiting from programs like this. To be clear, all of this time, once Python gets to the bottom of your file, it's going to exit anyway, so I'm using sys.exit now just to make sure that I exit earlier than otherwise.
My question is about the sys.argv.
I'm going to finish the segment that we're on and then call it a night because I've kind of checked out. Like, I didn't type anything that he typed at last. I'm getting tired. Been at it for quite a while, so.
So is that capable of accepting or taking multiple elements at once? Let's say, for example, Python name.py, David Malin, I'm a male, 20 years old. And if, let's say, I only want to access your name, which is at the first index, and then your age is say at the 6th index, can I say sys.rv1 and another one for 6 to access what I just want? Is that possible for sys.rv?
Short answer, yes, I think, if I understand your question correctly, whereby you're proposing to have many words at the end of the command and you want to access those individual words. Absolutely. At some point, it gets a little fragile, I would say, if you're typing so many words at the prompt that the order really matters. And so it turns out there's a lot of programs and there's functionality in Python that can allow you to provide those values like name or age or any number of other fields in any order you want, but pass in a bit more information textually that tells the program how you want to use it. So in short, what you're describing is possible, and let me do a small incarnation of it as follows. Let me propose that we go back to my code here, and let's propose that we actually now want to support multiple values at the prompt. So there's going to be no such thing as too many arguments. Suppose that I want to generate name tags, not just for David, but for David, for Carter, for Rongshin, for others in the group who all want their name tags as well. So I'm going to go ahead and do this. I'm going to get rid of my elif condition because I don't want to limit the maximum number of words that are typed at the prompt anymore. I instead want to iterate over every name at the prompt. So I'm going to say this. For arg in sys.argv, go ahead and print out, this time, arg. So what am I doing here? Well, even though the syntax is a little different, the idea is the same as before when we've had loops. I'm using a for loop to iterate over a list. The list in question here is sys.argv. Arg is a variable that I'm creating on the fly. The for loop is going to make sure that the first time through this loop, arg is set to the first word on the command line. The second time through the loop, Python's going to make sure that arg is now set to the second thing on the command line, and so forth. That's just how a for loop works. It updates the variable for us. I don't have to call it arg. I could call it name, so long as I change it to name in both places, but arg is reasonable if I'm iterating over arguments more generally. If I now run this program, though, unfortunately there's a little bit of a bug. Even if I type in David and Carter and Rongshin, I'm not going to get just 3 name tags. In your mind, does anyone see the bug I'm about to trip over? It's not a huge deal if I've got enough name tags to go around, but I'm going to be wasting one because this is going to print not 3 but 4 name tags, whereby the first contains the name of the program itself. Maybe not a big deal, maybe that's the sticker we don't bother handing out, but it's wasteful and it does look wrong. So how could we get access to not all 4 elements of argv, but just a slice of argv? And this is actually a technical term in Python and some other languages to take.
We are on slices. Try to remember slices, because I don't know if it'll save, because I didn't save my spot in the last video, so try to remember slices. But we're going to call it a night there. I was hoping to get through it, or at least get to midnight, but we're 20 minutes early, and I've completely checked out, so that's not fair to CS 50p EDX or any of those, because yeah, at that point I'm just sitting here staring at it and not actually interacting with anything. So just real quick, the final housekeeping. The reason why I get to do this is because they have a very generous license where I can copy and redistribute the material in any medium or format. You can too. You can do this too if you want to stream this stuff. Should be good. Adapt, remix, transform, and build upon the material. I'm trying. I don't have a whole lot to add to this besides a lot of wrong guesses. And down in the box below, down in the description, I have a link to this EDX class. You can sign up. You can take it completely free. You get a little certificate at the end when you complete everything. And you can pay some money and help support them and get like a fancier, I think it's a validated certificate. This is not monetized in any way. It's not my channel is not monetized. If one day it does become monetized, I will go back and unmonetize these videos. I don't have any links to tip jars or anything like that in these videos. And if you do get an ad on this video, like if you're part of the Glitch Gang rewatch group, I like that, Glitch King. It's not me, it's YouTube doing it, so I'm not making any money off of it. But I guess YouTube still needs to pay their bills, so whatever. The same license, YouTube does their own licenses. However, if you for some reason decide to use this content, my content, as for any reason, you don't have to worry about a copyright strike from me. You can use it however you want, any way you want. And I think that's about it for that. So we made it through lecture 4 is actually lecture 5 because it starts at 0 because I guess they're being cute with the programming counting. So we did quite a bit because I think we were halfway through lecture 2. So we did half of 2, we did all of 3, and half of 4. So we got a pretty good chunk done. Tomorrow, I'm not exactly sure when I'll pick this up again. It might be later. It might be at our normal time. I might start early because, like I mentioned at the beginning of the stream, I have the kids Wednesday through Monday this week, and I don't know if I'll be able to do any streaming. And since I'm on vacation and I don't have school this week, we're on a little break, I kind of want to get this done this week. So maybe I can get it done, maybe I can't, but I want to try. I'm hoping that if it's not done by tomorrow, which we have a long ways to go, there's still a lot of videos. A lot of the videos coming up are 2-3 hours long. That would be that would make tomorrow a really long day. I don't think that's going to happen. So I'm hoping that we get a big chunk of it done tomorrow, and then hopefully the kids let me stream some Friday, Saturday, Sunday, Monday, but we'll see. I'm hoping to bribe them with some Phasmophobia streaming, hoping that if I can get them to, do a couple hour Phasmophobia stream, they'll let me, stream a couple hours in peace. You never know, though. They're kids. So as soon as they see me streaming, they'll probably want to be in here and be goofy. So we'll see. Anything else? Please like, share, subscribe. Subscribe if you are new here. I'm hemorrhaging subscribers right now because this is a complete change to my old content that's no longer a thing. So as people see me streaming this instead of that, they are leaving in droves. So which was expected. I don't expect people to stick around if they're not interested in it. But if this is something you're interested in, please consider subscribing and sharing with those who you think would be interested in this. Help the channel grow. That'd be awesome. And if you are part of the Rewatch crew, comment down below. Comment something, and I'll read all comments. And yeah, I'm going to bed. So cheers, peeps.